Making a Choropleth map with React and D3. Our goal is to reproduce this Choropleth map based on this dataset. This missing migrants on a map visualization is pretty similar to what we want to do in that it loads a background map and it also loads data from a CSV file and visualizes that. Therefore, I'm going to start our Choropleth map by forking this visualization. And then I'll rename it to be called HIV/AIDS Choropleth map. The first code change I'll make is to make it load our HIV data. Over in useData.js, I can just change this CSV URL to be the raw URL of our dataset. I'll copy this one here, go back to our code, and paste it as our CSV URL. Now we need to update our row parsing function. I'm going to delete this outdated location coordinates parsing. And instead of parsing total dead and missing, we need to be parsing prevalence-HIV/AIDS, this big long string. So I'll copy this from the CSV file, and then I'll paste it here. And just to make our downstream code easier to work with, I'm going to make a new property called d.aids, just so we don't have to deal with this big long string ever again. We can check to see if this worked by saying if data console.log data. And in the console, we've got this array of objects, each of which has an AIDS property. And a year. See, here's one for 1990 and then another one for 1991. This is kind of problematic because a Choropleth map can only show a single year. We've got a mismatch where our data contains values for multiple years for any given country, but the map, a Choropleth map, can only show the values from a single year at any given time. So how do we reconcile these differences? Well, I think we just need to pick 1 year to show on the map for now. Maybe later we could add like a time slider or something like that, but the first pass will just show a single year. So the question is, which year should that be? If you look at the CSV file, you can see that it goes from year 1990 up until year 2017. Since that's the most recent, I think we should just show the data for 2017 on our map. But how do we do that? Well, we could use JavaScript arrays built-in .filter method to exclude all the rows that are not for the year 2017. But in terms of the code, where do we put that filtering logic? We could put it in useData and have useData just return that array that only has that 1 year. Or we could introduce a new separate piece of logic to deal exclusively with the filtering. Which is better? Considering we want to develop flexible code that works for our case now of showing a single year, but would also work later on if we wanted to dynamically change that year with a time slider, I like to think of the single responsibility principle. The single responsibility principle is a computer programming principle that states that every module, class, or function should have a responsibility over a single part of the functionality provided by the software. And that responsibility should be entirely encapsulated by the class, module, or function. We can apply this principle to our situation by introducing a separate module to do the filtering. That way, useData will be responsible just for loading in the raw data. And then there can be some other chunk of code just responsible for doing the filtering. That's how we can apply the single responsibility principle. All right, so back in our code, useData is doing its thing. It's doing the right thing. So I'll delete that console.log statement, and then I'll go over to index.js, where we can introduce something that computes the filtered data. If the data does exist, we can compute filtered data and set that equal to data.filter, pass a function that takes as input one row, d, and this function should return true if d.year is equal to the selected year, which is not defined anywhere, so I can just define selected year to be 2017. Now let's console.log the filtered data and see what we see. Now this array only has 231 entries, and each of these entries is for year 2017. Now we're in a situation where each row represents a different country. All right, we've got our data in place. Now let's investigate that code that is drawing the map to see what needs to change there to make it into a Choropleth map. After our code that sets up the filtered data, there's a bunch of logic to set up a size scale and a size value accessor. But in the case of a Choropleth map, we're not going to use size, we're going to use color instead. So at this point, I think I'll just change size to color. First, I'll comment out this console.log statement, and then I'll define size value to return d.aids, which we created in our data parsing logic. Max radius we don't need anymore, so I'll delete that. And then I'll rename size value to color value. And instead of size scale, let's create color scale. But what kind of scale will this be? The way I'd like to set this up is have it be sort of a continuous color ramp. To accomplish that, we can use D3's sequential scales. In the D3 scale package, one type of scale it provides is the sequential scale. With sequential scales, the output range is typically specified as an interpolator rather than an array of values. The D3 scale chromatic package provides a bunch of these interpolators that you can use, such as D3.scheme blues, scheme greens, grays, oranges, purples, interpolate turbo, interpolate viridis, interpolate inferno. There are a ton of these available. Since our goal is to reproduce this Choropleth or something like it, I'm going to choose an interpolator that's kind of similar to this one. This one here looks pretty similar, D3.scheme YLORRD for yellow, orange, red. To use this, we need to import scheme yellow, orange, red and scale sequential from D3. And then our color scale can be an instance of scale sequential. And with sequential scales, instead of passing a range, we need to pass the interpolator into the constructor, like this. That's how you can set up a sequential scale. The max here uses size value, so I'll have to change that to color value. Now, when we render our marks, instead of passing size scale, we can pass color scale, and instead of size value, we can pass color value. All right, now we need to start making changes to marks.js. In marks.js, first of all, we need to take as input color scale and color value. And then what changes do we need to make down here? Well, first of all, this whole segment that renders circles for each data element, we can just delete because we're not making circles anymore. Instead, we're going to set the fill of these paths. This code renders one huge path for all land. Instead, we need to render many paths, one for each country. Instead of land.features.map, this should be countries.features.map. And countries we need to get access to from what gets passed in as World Atlas instead of land. So I'm going to replace land here with countries. But where does this World Atlas come from? Well, over in index.js, World Atlas is just World Atlas, which comes from use World Atlas, which is defined in useWorldAtlas.js. And in this file, we have access to countries here, but it's not getting exposed when we call setData. Instead of extracting a feature from the topo.json for land, I'm going to extract it from countries and then assign that to the key countries in this object. Now we are actually rendering different paths for different countries. Back in marks.js, we're setting class name to be land, which I don't think we need anymore. I'm just going to get rid of that. And in styles.css, I'm going to get rid of the land style, which just sets the fill. For that matter, we don't even need this .marks style anymore. Now all of our polygons are black. Alright, so when we're making these paths, one for each country, we're going to want to set the fill of each one of these to be color scale of color value of D. But D is something we don't have. All we have is the feature. And what is this feature anyway? I'm going to convert this to a function with a body and return this path explicitly so that I can say console.log feature. Here's our feature object. It has a geometry which is used to render the polygon, but it also has a property called properties with another property inside of that called name that gives us the country name, for example, Zimbabwe. Therefore, we could log out feature.properties.name and then get Zimbabwe. Alright, we've got the country name for each country, and from there we need to look up what I'm referring to as D, the original row from the table that matches up to that country. But how do we do that? Well, if I were to do it manually, I could just hit Control F and type in Zimbabwe, and then look up the value for 2017 and find out that this is the number, and then pass in that number to our color scale. To do this programmatically, we need to introduce some kind of a lookup table where we can give it the country name and it will give us back the row from the table that corresponds to that country name. One way we can do this is by using an ES6 map data structure. A map holds key value pairs. You can construct a map by saying new map. You can then call map.set key and value, and then later on you can call map.get, passing in a key to retrieve the associated value. Let's use this map data structure to set up a lookup table where the keys are country names and the values are the rows from the original data table that correspond to those countries. This lookup table is the missing link that we need to go from country name to D, the row from the table. Let's assign D to be row by country .get feature.properties.name. Now our task is to set up the row by country map. This is something we can pass in from the outside instead of data. So now over in index.js, when we render our marks, we should pass in row by country equals row by country. And now let's define row by country, which will be derived from our filtered data. I'll define row by country to be a new map. And then for each row of our filtered data, called D, we can call row by country.set. The first argument will be the country name. Looking at our CSV data, that's going to be a property called entity. So the key will be d.entity, and the value will be D itself, the row itself. Now let's take a look at row by country, console.log row by country. We get this map instance where the keys are country names and the values are the original rows from the table. All right, so far so good. Things should be working. I'll get rid of this console.log statement, and nothing is showing, so now it's a matter of debugging what's going on. We get an error that says u is not a function at marks.js line 19. Here's line 19. It's the one that sets the fill using the color value of D. Let's just console.log various things to make sure that everything we need is in place. First, I'll console.log D. We see the object, the original row for Zimbabwe, so that looks good. Now let's console.log color value of D. That gives us the number 13. That looks pretty good. Now let's console.log color scale of color value of D. It looks like that is not working. So what if I just console.log color scale? It does look like a function. I'm not really sure what the problem is. I wonder if there's something wrong with how we set up the color scale. I'm going to go back to index.js, and I want to make sure that this scheme was imported correctly from D3. So I'm going to say console.log this scheme here. Oh, it's an array of arrays. You know, I don't think this is the right thing. Yeah, we need to use an interpolator, not this scheme. Let's go back to the documentation. Instead of using scheme yellow, orange, red, I should have used interpolate yellow, orange, red. If it starts with scheme, it's the discrete version that has, sets of discrete different colors, whereas what we want is the interpolator, the continuous version of the color ramp. All right, I'll get rid of my console.log and change scheme yellow, orange, red to interpolate yellow, orange, red. And then when we set up our color scale, I'll pass that in. Now we get another error, cannot read property age of undefined. This suggests to me that some country names don't match up with the country names in the data, or maybe there's missing data for certain countries. In the case that there is no row, in the case that D is not defined, what should we do? Should we just not render that country, just leave it empty whole? Or maybe we should render it a special color that represents missing data? I kind of like that approach. In that case, we can say, is there D? If so, use the color scale. Otherwise, use the missing data color. And that missing data color I can define up here to be, I don't know, let's use red for now. All right, we get some colors. But red may not be the best choice because the color scale has red in it. So how about, let's use gray as the missing data color. Okay, now it's more clear. All right, we're getting pretty close. I suspect at this point it's just a matter of the names not exactly matching. Let's figure out which countries have missing data and then see if there is actually data in the data set for that country using a slightly different name. And if there is, we can make them match up somehow. In the code, I'd like to know which countries are missing. So here I can say if there is no row for the given country, then console.log feature.properties.name. All right, we've got a list of all the countries whose names don't match. Vatican, Micronesia, Marshall Islands, U.S. Virgin Islands, United States of America. There are actually quite a bit of mismatches here. My original thought was, well, there might be a couple that don't match and we can just sort of fudge it to work, but I don't want to be fudging so many mismatched names. Perhaps a better approach would be to use codes instead of names. But what codes do we have available? In our CSV data, there is a row called code, and we get values like AFG, ALB, ARM, but what are these codes? I'm pretty sure these are ISO 3166 country codes. ISO stands for International Organization for Standardization. These codes look like AFG, ALA, ALB. These are the Alpha 3 codes. All right, these are the codes we have in our AIDS data. What about the topo.json? Well, in the World Atlas Project documentation, we see that for world.objects.countries, each country exposes country.id. the 3-digit ISO 3166 numeric country codes. All right, so we've got the numeric codes from the topo.json, and we've got the 3-letter codes from the AIDS data. There is a one-to-one correspondence to these codes, and I think we're going to have to find a data set that represents that correspondence and pull in that data set so that we can make these data sets work together and resolve the numeric ID to the 3-letter ID. But how do we do that? I mean, where does that table come from? Well, here's a table right here in Wikipedia that says for the alpha 3 code AFG, that corresponds to the numeric code 004. Ideally, we could get this table into CSV format. I wonder if such a CSV exists already. I guess I'll just have to dig for it. I just did a Google search for ISO 3166-1 CSV, and it looks like there's a CSV right here. This looks like a pretty well-maintained project. It says these lists are the result of merging data from 2 sources, the Wikipedia article and also the UN statistics site. It says here 3 versions exist for each format: All, Slim 2, and Slim 3, which just has the English name, numeric country code, and alpha 3 code. It looks like Slim 3 is what we need. Under the Slim 3 directory, we've got slim3.csv, which weighs only 5 kilobytes, and it's got what we need, alpha 3 and the country code. I can just use the raw URL for this CSV file. I'll copy this URL, and back in our code, we need to introduce another piece of logic or another module that will actually load in this CSV file. useData is already doing something very similar. So I think what I'll do is I'll make a new file called usecodes.js, and then I'll copy all the logic from useData into usecodes. And then I'll change the CSV URL to that URL that I had copied earlier. And with this data, we really don't need any parsing function because we're just dealing with strings. So I'll delete references to our row function. And I'll rename this export to usecodes. All right, now in index.js, we can import usecodes from /usecodes. And in addition to useData, we can invoke useCodes and then assign that value to a variable called codes. And if there are no codes, then let's display the loading indicator. To check if this is working, I'm going to say console.log codes. All right, this looks good. Each object has alpha 3, country code, and name. All right, now that we've got this in hand, we need to connect all the dots. Now that we're going to use codes, this whole concept comes into question. Do we really want row by country? Well, we need row by something, and that something that we have from the topo.json data for each country is the numeric code. So I think I'll rename this to be row by numeric code. And then as we iterate through the filtered data, we're going to set on row by numeric code the value of D, the row, but the key, instead of being d.entity, it's going to be the numeric code. And numeric code is something we need to derive from D. And keep in mind, D is one row from our CSV data about AIDS, which has a column called code that resolves to these alpha 3 codes. So I can say d.code, but this is not numeric code. This is the alpha 3 code. So how do we get from alpha 3 code to numeric code? We need to somehow define numeric code as a function of the alpha 3 code. Well, I think we need to set up a new lookup table where the keys are alpha-3 codes and the values are numeric codes. Assuming we had such a map and it were called numeric code by alpha code, we could invoke .get, passing in the alpha-3 code in order to retrieve the corresponding numeric code. Now we need to assemble this lookup table. So let's do that right here. Let's say const numeric code by alpha code equals new map, and then for each code we can invoke numeric code by alpha code dot set, where the key will be alpha-3 code and the value will be numeric code. Now we need to define alpha-3 code based on code, and I don't remember the structure of this, so let's take a look at the console to see what each of these code objects looks like. Alright, the columns include alpha-3 and country-code, which I'm going to copy because we can use those to extract the values. So alpha-3 code will be code at the property name alpha-3, and then numeric code will be code at the property country-code. Now this numeric code by alpha code map should be set up. To verify that, let me just say console.log numeric code by alpha code. This looks good. It's a map that maps the alpha codes to numeric codes. Great. Now let's check if the downstream code is working. Did this thing get set up row by numeric code? Let's find out by saying console.log row by numeric code. This looks pretty good too. The key is the numeric code and the value is the original row from our table. All right, all we need to do now is to modify our marks rendering logic to take advantage of this new lookup table. Now that we've got row by numeric code, we can pass this into our marks, which was previously expecting row by country. So I'll change that to row by numeric code. And then over in marks.js, we can unpack row by numeric code. And then in our rendering logic, instead of using row by country, we can say row by numeric code. And I believe it was available at feature.id. All right, now we get a map that actually looks somewhat complete. All right, that's how you can make a Choropleth map with React and D3. This map is what I have got working so far. I was just messing around with open layers and these Firefly cartography map markers, and I got it to work. But it's just a first pass. It's very rough. I'm not really proud of this. It's not a useful visualization. It's useful in that you can tell that it's a worldwide phenomenon. Here's the first version of this, where the dataset had more points, actually, like around San Francisco, more detailed locations. Yeah, this visualization here pulls in the coronavirus data. So if we take a look at the code, it's just this use data thing that I put together in another point in time. You know, since I want this to be part of the course, what I'm going to do here is start from scratch. So you can follow along each and every step that it takes to get from 0 to hero. So the first thing is, let's get this URL loaded into a brand new program. So what I'm going to do is, first I'll sign into VizHub. And by the way, anyone following along can do the same. And I'm going to go to create a new visualization based on just, actually probably loading and parsing CSV data would be a good place to start. Yeah, so I'm going to fork this so I don't mess up the original, which I have often done. Fork that. And now let's set our intention of what we're doing here, which is loading and parsing coronavirus data. I would like to use ES6 and everything rather than just straight HTML. So I'm gonna migrate over to a bundle.js approach. Source equals bundle.js, and that file will be created from this new file, index.js. This is a special file name that's picked up by VizHub internally, and it's bundled using rollup. From index.js, bundle.js gets created, and it pulls in all modules from different files, puts them all into one file, so that you can author your code with ES6 modules, which is what we're going to do. So let me just take this content and move it to index.js, and then I'll auto-format with prettier with Alt-P. You can do that in VizHub too. Alt-P, boom, prettify the code. I think it's working. Oh my gosh. Is it really working? That was fast. I'm going to clear out the README because it's outdated. And then I'm going to get that URL. So the question is, here's a URL where it's pulling the CSV file. How do we change this to get the coronavirus data? Well, this URL here goes to some random data set that I've used in the past. And to make it the coronavirus data, we need to go into this GitHub repository. And then, oh, I love how it's updated so frequently nowadays. You know, this is up to date. It's great. So I'm going to go into this directory, CSSE COVID-19 data, and then we've got daily reports versus time series. Now, I don't really know what I'm looking for, but I think I'm looking for the time series. Yeah, see this? There's 3 different files. One for confirmed, one for deaths, and one for recovered. I would like to look at all these eventually, but since deaths now are on the rise, I think we can start with this one about deaths. So I'm going to click on that file. And let's just take a look at the table structure for a minute before we pull it in, because as soon as we pull it in, we're going to have to deal with this table structure. We've got province/state, country/region. So province/state is a more detailed thing than country/region. For example, in Australia, we've got New South Wales and Victoria and Queensland as separate points in this data set. But I don't see one for Australia as a whole. Is it there? See, that's one thing that might be a little weird about this data set. It's like they have the breakdown, but they don't have the sum total for Australia. So we might have to calculate that ourselves. So that's the first 2 columns. And then we've got latitude and longitude, which means we can put it on a map, which is sweet. And then we've got dates. Each date is its own column. So if I scroll all the way to the right, you can see the latest date is 3/20/20, and they're just adding another column every day to this. So I'm thinking what we can do is pull down this data and then interrogate the columns to see what is the last column, and just use that, whatever it is, because it's going to change every day. To pull this data in to VizHub, what we need to do is click on this raw link right here. And that takes us to a URL that resolves to the CSV data, and it's not tied to any particular commit. You can get URLs that are tied to a particular commit, and that's what you would want to do if you want it to be stable and never change and never break. To get a URL that resolves to a particular commit, you go to the home page for the repository, click on commits, 424 commits, and then take the most recent one and then say browse files. Right, so see how this here says tree? It's a particular commit. And if you click on raw here, you get this URL that resolves to the CSV file for that particular commit. And you can see it in the URL there that I highlighted. And this means that this link will never break unless they take the repository down. But we can use it here. So I'm going to get rid of this old CSV URL and put a new CSV URL. And it should be there. Let's just do a little exploration. Console.log data. And then in the developer tools, so we have this array of 447 entries. And this is the data set. See that? This is the coronavirus data set. Woohoo! We got it done! All right, so this is like phase 1 complete. Yeah, it's just the same things from the table. Good stuff. And in addition to being an array, data, which is returned from d3.csv CSV URL .then data. So it's fetching this URL and then giving us the parsed data. And when D3 does this, it not only gives you an array, but it gives you this columns property, which is an array of the columns. So check this out. Here's what we can do. We can isolate the most recent date of this data by getting, at index 62 of the columns array. So data.columns at index 62 is going to be 320. And so this will work, but if a new day is added, if we just hard code 62, it's just going to give us this day forever. So what we want to do is take the last entry. So how do we take the last entry of an array? We can say data.columns.length. That'll overrun the array, so it gives us undefined. But if we do data.columns.length -1, then we get the last entry. So the idea is we can use this to sort of select which date that we're looking at. So let me just take this aside as a variable. I'm going to say const latest date column, just so the code sort of is very readable. But coming back to this issue of having the data set tied to a commit, with this particular visualization and this circumstance, I don't think I want it to be tied to a commit, but I just wanted to show you how to do that, if that's what you want, stability. And I'm going to keep this around in case the data set does break or they take it down. I'm going to keep this whole thing commented out. And I'm going to put the URL that's not tied to any specific commit. So I'm commenting out that old one. I'm going to put a new one here that's going to update every day. It's going to update every day. It's going to be so cool. So I'm going to back out from here, and instead of looking at this one commit, I'm going to look at the master branch, raw, and then now this URL, if you access it tomorrow, should have one new column. And so the visualization should automatically update. That's what I want to get at here. So yeah, this old URL that has a commit is not going to update every day, but it's going to be stable. It's not going to break. This new one, which I'm going to paste right now, boom, it's going to update every day, but if they change the name of the file or something, our visualization will break. So just something to be aware of. All right, we have loaded and parsed the coronavirus data set. Imagine that. One last thing just to make this piece complete is I need to update the README to say this program loads and parses the Johns Hopkins coronavirus data set. Yeah, so I'll just link that. All right, we have loaded and parsed the coronavirus data set. All right, so we've loaded and parsed the data set for coronavirus. The next thing I wanted to do is write some code that calculates the sum total number of deaths as of today and just displays that on the screen. So I'm going to start by forking this one here, and then I'll set my intention by changing the title to be summarizing coronavirus data. All right, so we've got this data here, And we've got the latest date column. And then we're constructing this message, which gets rendered on the screen eventually. I don't care about this stuff so much as the number of deaths. So let's sort of scaffold out how we're going to display the message. We'll just write deaths. That can be const. I don't know. I think it had to be let before. And so I want to have ultimately something like a death total as a number. And I'm just going to put in 10,000 as a placeholder because I know it crossed 10,000 yesterday. And then we can just say as our message, death total plus space deaths total. Oh, and this needs to be quoted. Yeah. Okay, it says 1,000 deaths. Total goes off the screen. We'll just keep it like this, 10,000 deaths. All right, that's how we can display our message. How do we calculate the sum total? Let's take a look at data. Console.log data. And because the data set does not contain overviews for countries, like for example the US, it only contains rows for US states. It does not contain a summary row for the entire United States, and same thing for Australia and probably some other places. So that means that we should be able to just sum up the values in all the rows to calculate the sum total global number of deaths. So let's try that. When I say console.log data, we get this array, and I want to sum over that array. But first we have to map over that array to get all the numbers to sum up. So we can say data.map using the built-in array.map that takes a function that takes as input one row. I'll call it D. And we can return D at latest date column. And that worked. We've got these numbers that are the number of deaths for each and every country for the most recent date. But they're strings, not numbers. To parse these into numbers, we just can add unary plus right here. And boom, we've got the numbers. Now, we need to sum up all of these numbers. For this sort of thing, I like to just figure out how to do it in the console and then put it into the code. So let's say we have an array of numbers 1, 2, 3. That should sum up to 6. The way I would do the summation is to use reduce. And this is something that's built into JavaScript. It's kind of like map. Array.reduce takes as input a reducer function. And that function takes as input the accumulator and the current value. The current value is the value in the array, the number. And the accumulator is what got returned from the previous invocation of the reducer. And it also takes as input, let me see, array.reduce. It also takes as input the initial value of the accumulator. And so to implement sum using array.reduce, the initial value will be 0, and the accumulator will just be this same one here that just adds two numbers together. So I think I'll just grab this code from here. Looks like exactly what we need. Back in my console, I can just use this and have as the second argument 0, just to make sure that we initialize our accumulator. Okay, so that computed the sum. See that? Pretty cool. And what we could even do is define this as sum. And then we can say array.reduce and pass in sum. That'll do the same thing. Okay, so I'm going to take this code and use it inside of our program. All right, so let's define sum right here. It's just that copy-pasted reducer function from the MDN documentation. And we can just apply that to this array of numbers right here by just appending a dot reduce. Sum will be the first argument and 0 will be the second argument. And that should be our death total. So if I just put that there as the death total, it appears to have worked. See that? 11299 deaths. And let's see how that compares to the Johns Hopkins version, because that's how we would know if it's correct or not. Okay, so in the Johns Hopkins version, it says total deaths 11906, and then in our thing it says 11299. Huh. What if I go back to the day before that? Huh. Okay, well this is concerning because these should match. These should match up. I don't know, maybe they have slightly more up-to-date data than we do. It says last updated 3/21, but our most recent date is console.log latest date column is 3/20. 3/20. So it looks like they have not yet updated their CSV file here. Okay, but hopefully when they do, it'll be matching up to what they have. I think this is the reason why they don't match. But that's all right. All right, we've got it. We've done it. We have summed up the number of deaths. Now I just want to tweak the presentation of this so that it's something that I could show someone. One thing I want to do is fix the number formatting, like add a comma in there. And then also, I think the program should display, as of which date. So let me focus on that piece first. If I just add as of with a new line, yeah, now we can as of, and then I can just put the latest date column. Okay, great. And now I just want to format this number, and we can do that with D3 format. So let's import format from D3, and I believe we can just define a formatter. I'll call it comma formatter as D3 format and pass in just a comma. Pretty sure that's how it works. And then we can pass a number into this function and it will return us a formatted string. And so we should say formatter of death total, and there we have it. And I'll just prettify this. Alright, and this could be actually a little bit bigger. I'll make the font size 8 or 9 EM, maybe 8.5. And I just feel like making it not exactly black for some reason. So we can set the color to be black and then change it here with this color picker, and it updates in real time. A super cool trick. Oh, my face is in the way. Sorry about that. So yeah, let's make it red because it's dire. Alright, and then I'll just take this, I'll just copy this color into our styles here, and we can say color is that, and boom. Alright, very good. So there are 11,299 deaths as of yesterday, not today. But this is pretty much where I wanted to get to. Alright, so we have sort of a jumping off point. We've got the data in, we're summarizing the data, and from here we can break it down further. So this is where we got to last time. 11,299 deaths as of 3/20/2020. This is the most recent number of a series of numbers dating back to, well, let's find out. Check this out. If we just do console.log data.columns, what do we see? 63 points. So we've got 63 data points in this time series. And they are, oh, well, actually, they just start at 122. So it's around 60 or 59 or something. But going back to January 22nd, we have data that we can show in this line chart, which we're about to make. I was thinking the best way to show all of these numbers is a line chart, because, yeah, this is just the latest number. And you know what I wanted to do? Let me try this. So now I wanted to share this idea that I had for this line chart, because, you know, just yesterday they announced that it had crossed 10,000. And in my mind, I'm like, wow, that's a milestone that you could represent very clearly in a data visualization. So here's my idea. We show a line chart with the number of cases, which probably looks like that. And then we have a line, and that line means 10,000. And we should have dates. You know, these are specific dates that we should show in the visualization. And we should probably show now as well, which is always shifting, but we could show it. So this is the idea that I had for the visualization to make, and I think we can make it. The first thing to do is draw this line. So I'm going to focus on just getting this line to work, and then we'll take it from there. Now that we've got this starting point for a line chart, we need to make it into a line chart based on what we've got. And let's just review quickly what we've got. We are loading the live data. We are figuring out what the latest date is in the data, and then summing up the death total just for that latest date column. And then we're displaying this message that shows blah, blah, blah. So where should we go from here if we want it to be a line chart? I think what I would like to do is set up the React infrastructure and do this whole thing based on that. So I think I'll just go ahead and actually fork this one and work backwards, because this has all the React infrastructure that I want in place to be making this line. And here, in this new fork, I'm going to change the title of this one to set our intention to say this will be the coronavirus line chart. So what have we got here? We're pulling in React and we're pulling in D3. So we have all of that at our disposal, and this program makes a face. So I'm just going to totally gut this program, and instead of making a bunch of faces, I'm going to make a line chart. And so conceptually, I want to have a line chart component, and I want to pass in the data as data. And I think the app should be responsible for orchestrating everything, which means wait for the data to load, and then once the data is loaded, show the line chart. And we could have some intermediate data loading phase too, say like loading until the data is loaded, but it's not strictly required. So anyway, let me just put placeholders for data. This is going to be an array of objects, and also line chart. Const line chart. It's going to be a React component, and for now, let's just return an SVG. Nothing more than that for now. And our app needs to return this line chart, and we got to close out these curly braces. So now this is our complete program, and I just want to remove some of the leftover things from before, like face.js. I'm going to delete face.js and facecontainer.js, delete that. I'm going to delete the eyes, delete the background circle, and delete mouth. So all we're left with is an out-of-date README, which is, I'm going to also delete that stuff, and a main program that just generates an SVG. And we've got some width and height left over, but we're going to need to know what the width and height is anyway. The way that I like to do this is to actually measure the browser window. And so that way, if you resize the browser window and refresh the page, it would get the latest coordinates or, get the latest dimensions. In VizHub, the size is static, but I like to write code such that if you were to export it out of VizHub and run it, you could resize the browser and refresh, and it would do the right thing. So the width can be, I believe it's document.body.client width. Let me just console.log width to see if it's the right thing. Oh, it got some errors. Uh-oh. Red alert! Face does not exist. Okay, that's fine. We can just delete that import. Hey, 960! Sweet. That's correct. So document.body.clientWidth returns 960 because that's just what VizHub uses for the width. And we can do the same thing for height. So I'm just going to replace width by height and width by height. Looks like we got a syntax error. Oh, height is defined twice. Hey, where's my Vim mode? So Alt-V, by the way, turns on Vim mode in VizHub, which I like to use. Feel more productive. Okay, so height is defined twice. That's what's going on.
Okay, then when you are using line chart component, you are giving it data.
Yeah, that's right.
So where it's not defined there, it doesn't need to be?
Well, yeah, that's a great point. It's still, this is how I'm sort of sketching it out. All the connections are not there yet, but one thing we're going to have to add is unpacking the prop data in the line chart component and doing something with it.
I'm so confused.
Yeah, but right now, data is just an empty array. And so when I add the CSV data to this app, that's when I'll propagate data through this line chart component. But I feel like we're not quite there yet because we need to size the SVG based on the browser window. Yeah, so this SVG and this array is something that's left over from earlier. I just want to get to a clean slate. An SVG gets a default size. So for example, if we were to style SVG to say the background color is red, see we get this little square? And that's because the SVG has a default width and height. And if we were to start working without doing this first, our lines and everything would be like just not in the right spot. Or they would be cut off because the SVG doesn't have width and height. So that's why we need to give a width equals width and height equals height to our SVG element. Something is weird here. It should be a full screen red thing, but I'm not seeing that. Is there a typo or something? No errors. So I'm going to try to figure out if the SVG element is the right size or not by inspecting the elements. Oh, height is 0. Why is height 0? Document.body.client height must be 0. So if I just console.log height, we get 0. Okay, this is the problem. We got to do a little bit of digging here to figure out, JavaScript height of browser window. There might be some, oh yeah, I remember now, it's window.innerWidth and inner height. What was I thinking? Document.body. Well, I guess it works too, but that's what it should be. So window.innerWidth and window.innerHeight. Okay, there we go. So now we are where we should be with respect to getting an SVG to fill up the screen. Now let's bring in that data that we had from the other program, summarizing coronavirus data. What I'm going to do is just copy paste some stuff from here to there. But first, let's strategize. How do we want to develop this data fetching logic? Should it be its own component? Should it be its own hook? I think it should be its own hook. So let's set up that infrastructure right here, and then we can move it to a separate file later. But let's make a new hook called useData. And this is...
What is a hook?
Yeah, what is a hook? That's a great question. So what is a hook anyway? If you do a Google search for React hooks, you see this example here. It says, hooks are a new addition to React 16.8. They let you use state and other React features without writing a class. And when they introduced hooks, this is when I really got into React. Before that, the classes sort of turned me off from it, but after these hooks, it's like it's such a beautiful way to write code and organize your state and your logic and everything, and it just serves all my purposes very well. And so this is why I think it's a good idea to use React hooks nowadays. Here's an example of state. Use state, which we are going to use to keep track of our data. When you use the React hook called useState, it sets up a local state within that component. And the app, in our case, is the top level component. And that app is going to keep track of this state called data, where when the page first loads, data, it will be undefined or null or whatever we want. I'm thinking just undefined. So if you don't pass anything into useState, the default value will be undefined. And then we can use the useEffect hook to fetch the data and then set the state to be the newly fetched data. And so these examples here can serve as sort of a boilerplate for setting up our data fetching in React. And this is just how you would do it in, if you're developing a React application. You want to componentize, separate everything, separate the concerns as much as you can. So if you could separate the concern of loading the data into a separate module, that would be great. And then you can write the rest of your app, the line chart, without having to add checks for, if data is null, which I see all the time, in older examples. But this is sort of the direction we're going with React hooks. So let's make a hook that loads in the coronavirus data. I started setting up this. It's just a function. And React hooks are just functions as well. It's just that they need to be invoked inside of a React component in order to work. So const data equals array. Instead of that, I'm going to say const data equals use data. And that has to be called as a function, because inside this use data function, we're going to use some other React hooks like state, use state, and use effect. So let's just review the React documentation for use state. Introducing hooks, this is where there's an example of use state. It looks like this. When you call use state, the first argument you pass in is the initial value of the state. So count, in this case, is going to start off at 0. And then set count is going to be a function that sets the new value for that state. And when that happens, the component is re-rendered, meaning this function gets invoked again when the state changes. So then the next time around, count is going to be updated to whatever you pass into set count, and that's what's going to show up right here. So that's use state in a nutshell. I'm going to start by copying this example code and then pasting it in our code right here. And instead of count, I'm going to have this be data. Data and set data. And just some of the technical details here. Use state returns an array with 2 elements. That's why we can use this ES6 destructuring syntax with these brackets to destructure this array that has 2 elements in it. And the reason why the React developers did it this way is so that you can pick your own names for these. So it could be anything. They had count, we have data, but the convention is that the current value is the first one, and then the setter function for that value is the second one. And the naming convention is set, camel case with whatever the name is that you're dealing with. And then this function is going to return data. It doesn't need to return set data because the app is never going to set the data. The data is going to be set from fetching the CSV file. And that's where useEffect comes in. Let's review the React documentation for useEffect. It says here the effect hook lets you perform side effects in function components. So here's an example. We invoke useEffect and pass in a function. And that function will be invoked. This is something it took me a long time to learn with React. It was super useful. It will be invoked after the DOM elements are rendered on the page. So that's how you can eventually hook into those DOM elements and do the D3 integration that lets you use like the D3 transitions and the D3 axes. In our case, after the component renders the first time, we want to fetch that CSV data. So I'm going to copy this example code into our useData hook. Oh, and we need to import these things. useState, useEffect from React. And this stuff is left over from the example, so I'm going to delete it. And check this out. We can invoke setData. So if I invoke setData with, say, an array that has number 1 in it, check this out. In our app, if we say console.log data, what do we see? Oh no, it looks like we've got like an infinite loop situation. That's weird. And you know why that is? It's because we left out the second argument to useEffect, which is the array of dependencies. See, if you leave that out, the effect gets run every time the component renders. So, and calling setData causes it to re-render, so it's in this rendering loop, and it can't get out. So that's why we need to add the second argument of an empty array. See, what happens now is that the first time this runs, 0 gets output, which is the initial value for data. And then the second time this runs, after setState gets called, this is our new value for data. So let's think about what should the default value be. I think the default value should be undefined. So I'm just going to leave out the argument. So now it starts out undefined, and then it gets set to this array. So that's how we can put in place our React hooks for this useData component. The thing that we can do next is integrate that code that we got working already with loading that CSV file of the coronavirus data. Well, actually, now that I think about it, we're probably going to want to put this into a separate file, not so as not to clutter up app.js, because it's already getting kind of long at 30 lines. So here's what I'm going to do. I'm going to split out useData into a separate module by creating a new file, naming it useData.js, and then cutting this definition and pasting it into useData, and then exporting useData. Now, over in index.js, we can import that. Import useData from /useData. And there's bound to be some errors because we need to pull over the imports. So here we're importing a bunch of stuff from React. We have to import that over here as well. Yeah, all we need is useState and useEffect. And check it out, it's working. It's working. All right, so now we have a place to sort of put all of our logic related to fetching the data. And also in index.js, we don't need these imports anymore for useState and useEffect. All right, let's load the CSV data. I'm going to copy CSV URL from this example that we have working. And then I'm going to go over to useData and paste that definition right here. And I'll put the commented out one too, just in case this viz breaks one day and could be restored by using that URL. And then we're going to need to fetch the CSV file. So in our new hook here, we can import CSV from D3. And then in our hook, we can say CSV URL, just like we had before, and then say .then data. And then this function here can be responsible for invoking setData. And then we just pass in data to setData. And this is a little confusing because these share the same name. So let me just say well, first of all, let me just test that this actually works. I think we're console.logging the data at some point. So at first it's undefined, which is when it's loading. That's to be expected. And then it's this array, which is the same array we saw earlier. Awesome. Now, I think we can simplify this code a little bit because this is just a function that takes as input data and then passes data into set data, which is a little redundant. We could just pass in set data itself like this, and it should still work. Yeah, it still works. Awesome. That's how we can define a React hook that loads in the coronavirus data. Now we are in quite a good position. See in index.js, we've got useData as its own separate module that's just concerned about loading the data. And then we've got line chart, which will be concerned about rendering the data. And this I'd like to pull out into a separate file as well. So I'm going to make a new file called linechart.js. And then I'll take this definition, move it into there, and add the export keyword. And then in index.js, import linechart from /linechart. And there's bound to be some broken imports. I think we need React. Ooh, reference error. Width is not defined. Okay, we can deal with that. We just need to take those as input as props. I think that makes sense to do it that way. Although it's just coming, it doesn't really matter. It's just coming from window.innerWidth and innerHeight. But in principle, the top level component should be able to tell that lower down component what its size should be. So I think I'll keep it like this. We just need to pass in width equals width and height equals height. Boom. All right, great. Now we've got our line chart separated in a different module, and it has access to the data. So in line chart itself, this is where we can say console.log data. Great. Now we're up to the task of transforming the data into a format that works well with D3, namely an array of objects, each of which represents a point in time. And that is not how this is set up right now. This is set up right now so that each date is its own column. So let's think about how can we do this. I think the line chart component should be able to expect properly formatted data for line chart as data. And so the current thing we're passing in for data is not really going to work. And I think in this case, useData could do the transformation in here. So instead of just passing in set data, I'm going to pass in a function that takes as input raw data. I'll call it raw data because it's not the same thing as the data that we're going to be referring to later. And I think really what I want to do is, call set data on a transformed version of the raw data. So I'll make a new function called transform and pass in raw data. I think that's a nice way to separate the concerns. And then we have to define transform, of course. So I think what we want to do is construct a time series data set where each row represents one of those months, or one of those days, sorry. All right, we need to figure out the set of dates first and foremost. So if I say console.log data, or raw data rather, we can see that the columns starting from the fourth column, the column at index 4 in the array, these are the dates, these are the values. So we are left with the task of isolating the dates only and getting rid of these other things. So this is a case where I like to figure it out in the JavaScript console first. We break it down into a very small problem. The problem is this. We have an array. It starts with A and B. And then it has 1, 2, 3. And we want to just get the 1, 2, 3, 4 and get rid of the A and B. How do we do this? I believe there's a thing called array.splice or slice. Let me just see what happens here. Oh yeah, slice of 1, slice of 2. See that? This is how we get rid of the first couple elements of an array. Great. And that was rawdata.columns. So we got rawdata.columns. Well, let me just console.log this first, and then assign it to a variable. We can say raw data.columns.slice, let's say 2. And that still gives us lat and long. So if we say .slice of 3, that should only give us long. See that? Just long. And so now if we give it 4, boom, we have isolated the dates. So this one I'm going to assign to a variable called dates. And what we want to do is compute the sum for each and every date and then return that data set. So we can do dates. So what we want to do is say return dates.map, function that takes as input a date, and we're going to want to return an object that just, let's keep it simple. Let's keep the date and the number of deaths, which I'll call deaths. And the deaths is going to be the sum. This is where we need to bring in the sum that we had working earlier. So we used array.reduce. And so I'm going to take this sum function, paste it here, so we have it available. And then I'm going to take this whole definition of death total. I'll return that as part of the object, the new rows. Looks like we got an error here. Data is not defined. That makes sense. We have to use raw data instead. And instead of using the latest date column, we use date. Oh, we got a reference error. Deaths total is not defined. Okay, it's just a mismatch of the names. I think this should be working now. If we just do console.log data, we see an array of objects where each one has a date and a death total. All right, this is it. This is how it should be. Except that the dates should actually be dates, as in JavaScript date objects. So I think the next thing I need to do here is parse these dates into JavaScript date objects. And we can do that with the help of D3 parse time, I believe. It might be in D3 time format. Parse. Yeah, there we go. Using D3 time format, we can create a parser for a certain date structure. And then we can use time parse to parse strings into JavaScript date objects. So the question is, how do we represent this format that we're using? So Zan Armstrong has this amazing example where she shows you all the different examples of date formats that you can use with D3 format time or parse time. And I'm pretty sure this is the one that we need, except for it's not 1986, it would just be 86. But I think that is just a lowercase y. Yeah, so this is how we need to do it. Something like this, but with the lowercase y. So let's try that. Back in our code, we can define the date format. And this is going to be the string, just taken from that example. But instead of an uppercase y, which would give us 2020, 2020, we just want 20, so that would be a lowercase y. And then with D3 time format, we can pass that into time parse. And by the way, what we're dealing with is called a specifier. So I think I should clarify that in the code. So instead of date format, this is going to be date specifier. And then we can import from D3, I think it was time parse. Yeah, time parse. And then we can define something called parse time, which is kind of funny inversion of time parse. You know what? I think I'll call it parse date equals time parse, and we pass in the date specifier, just like that. And I don't think we really need that variable. Okay, so now the date of the returned object can actually be parse date of the original date. And now that we have JavaScript dates and dates that are strings, this naming is confusing. So I'm going to update this to be, instead of dates, let's call it days, because they really represents days. And this could be parse day also. Yeah, this is looking better. Parse day, and we pass in day. And we got to use day here as well. All right, let's see what we've got. Hey, look at that. It works. We've got dates that are JavaScript dates that look correct, and death total numbers. All right, very good. I can clean this up just a little bit. Death total could be that inlined. Then we can get rid of the explicit return and just use these parentheses here. All right, now we're in a position where we can start making our line chart. I'm just going to clean things up and get rid of this console.log data here so we have sort of a blank slate. And then in linechart.js, this is where we can start creating our D3 scales. Oh, it's called untitled. Oh, interesting. I should have caught this title. Getting back to this sketch idea, we're going to need an x-axis and a y-axis. That means we're going to need an x scale and a y scale. The x scale is going to go from left to right, and it's going to represent our time, our dates. So let's create x scale. It's going to be a time scale, which behaves similarly to a linear scale in D3, which is just a linear mapping, but with dates. So we need to import this from D3, import scale time from D3. And with scales, you've got the domain and the range. The domain is the data values, the dates in our case, and the range is the pixel coordinates, which is going to vary between 0 and width because it's x. So we can define that like this. The domain of our time scale is going to be, well, this is where we need to pass in an array with two elements, the minimum and the maximum values. And we need to compute the minimum and maximum values over our dates. So we can use min and max from D3. And the way that we compute the min is we can say min, we pass in the data as the first argument, and the second argument to min is a function that takes as input one row and returns the value that it's supposed to take the minimum of, which in our case is date. And so I can say d.date like that. And same thing for max. Oh, and there's some error. Cannot read property length of undefined. Red alert. Okay, we got to back up here and take a look at what's going wrong. I think what's going wrong is we're passing data into line chart even when it's undefined. So let me just add a little guard, so to speak. It says if there is some data, return the line chart. Otherwise, return null. And this is the ternary operator. But if you haven't seen this syntax, it's the ternary operator. And it says if data is defined as something, if it's truthy, which it's not at first because at first it's undefined. If it is truthy, make the line chart and pass the data into it. And this is how inside the line chart we can be guaranteed that the data is defined. We add the guard outside of the component. But if data is not defined, we just return null. This is where we could return like a loading screen if we wanted to. I'll just make a little div that says loading ... just as a placeholder. Okay, so now that error is gone, and we should have a defined domain for xscale. Let's see. Let's say console.log xscale.domain. And if you call domain as a function, like this with no arguments, it just returns the domain. And so this is what it returned, and that looks correct, I think. Yeah, the data set goes from January 22nd, 2020 to March 20th, 2020. Yep, that's right. Sweet, we've defined our xscale domain. Now, let's define our xscale range. The range is going to be, again, an array of two values, the min and the max. In this case, it's going to be the pixel coordinates. And I want it to go from left to right across the screen, So the minimum value of the range will be 0, and the max will be width. And by the way, before we move on, I want to point out that you don't need min and max. You can use extent instead, and that will give you that array of 2 elements. So we can just call extent like this, and we need to import extent from D3, and it still seems to be working correctly. Great. Now let's define our y-scale. The y-scale is going to be the total number of deaths. And intuitively, I think this should start at 0, even if 0 is not the first value that occurs in the dataset. So let's make y-scale. Let's start using a linear scale and see how it turns out. I know this dataset, a log scale is better, but let's just try it with linear scale and see how it looks, and then maybe change it later to a log scale. So we create a new instance of scale linear, which we need to import from D3. We set the domain to be the extent across the data for D dot, what was it? What do we call it? Deaths total. There it is. Deaths total from each of those rows. So we can say D dot deaths total. But like I was saying, I think it really should have a 0 baseline. I don't know why I feel that so strongly. But the way it is here, it's not going to have a 0 baseline. So that's why we need to use max instead of extent, and then have the first element be 0 and the second element be max. Yeah, I'm going to do it like this. And I think max we need to import. And then the range of the y-scale, the minimum value should be at the bottom of the screen. And the y coordinate system is sort of counterintuitive. Y is 0. A 0 value of y is at the top of the screen, not the bottom. And then a height value of y is at the bottom of the screen. So that's why the range should start at height as the first one and 0 as the second one. Yeah, that's why it's flipped as compared to x. So let's do some proofing and just check if we got this right. Console.log yscale.domain. That looks correct, starting at 0, going up to 11,000 deaths. All right, I think it's working correctly. Now we need to define our line. I just want to put a line in here based on these scales. So let me take a look at the D3 documentation for making lines. And this is in D3 shape. D3 shape is what lets you make lines. Here's a link here for lines. The line generator produces a spline or polyline, as in a line chart. Okay, perfect. So it looks like we're going to need to import line from D3. So let's add that import here, import line from D3. And then once we have it defined, we can pass the data in to generate an SVG path string. But before that, we need to sort of specify how these accessors work. So we're going to have to specify the x and y accessor functions for this line generator. And the default is this. It returns d at index 0. So let's define our own line generator. I'll call it line generator because we already have something called line, which is imported from D3. So we need to tell this line how to project in x and y. And so I think it needs to be actually defined inside of our line chart after the scales are defined, because the x accessor is going to be a function that takes as input a row d and returns the x scale of the x value of d. And x value, I'd like to pull this out as x value. I'll define that out here. And then same thing for y. I'll just replace with the super duper vim commands that are working in VizHub now. Woohoo! I'll replace all x's with y's. Boom. But anyway, we can define y value now as well. And that would be a function that returns the death total. This one here. Okay, we got an error. Oh yeah, this is going to be y value. So now I think everything is set up properly so that the lines should generate. And all we need to do now is put inside of our SVG a path element. So instead of having this being like a self-closing JSX tag, I can add a closing tag, and inside the SVG we can put a path. This is how you make shapes and lines and stuff in SVG. You need to use a path element. And then the D attribute of this path element is going to be, and this is where it all comes together, line generator of data. Boom! We got something to show up on the screen. Woohoo! Oh man, look at that. That's something. That is something. Let me fix the fill situation. Yeah, we can just do with some CSS. Or we could do it in the JavaScript. It doesn't matter. I'll just say the line. I'll just do it with CSS. I'll say that the line has a stroke of none. Or no, sorry, a fill of none. Oh, sorry, this should be path. Path has a fill of none. Boom, okay, there we go. And the stroke is what we want to add. The stroke should be black. Oh, I'm in CSS, so I shouldn't quote things. Okay, there we go, there we go. I don't like this red background. It was just a test from earlier. Okay, that's pretty cool. We can set the stroke width as well to be, let's say, 20 pixels. That's going to be extreme. Well, not too bad, not too extreme. All right, we have created this very basic line chart of coronavirus data. All right, we've created a basic line chart for the coronavirus data, and it's pretty basic, but it shows the data. And so now we've got places to go and things to do, like maybe add in margins and axes and add that line for 10,000 and add that little line for right now. But I think that's enough for now. So we've got this basic line chart that shows the coronavirus data. Let me show you again the sketch. The idea with this sketch is that we can show this line chart. So we got the line working. That's great. There are some other components that I would like to add here. In the sketch, I had this idea of a line for 10,000 that was just crossed yesterday, and then another line for now. I think that would be cool. One line for 10,000 and one line for now. And you know, we can do all that without any D3 axes or anything. And I think it would be a nice, straightforward test of the our understanding of scales and how to put new things on there. So let's go about adding the line for 10,000. And then once we want to add the label for 10,000, that's when I think we're going to need the margin convention. But we can just add the line first, and then add the margins, and then add the label. So that's what I'm thinking we're going to do here. Should be fun. So we've got this basic coronavirus line chart. Let's go about adding that line that says 10,000. What does that look like? How should we do that? I mean, what file should be responsible for what? Let's just quickly review our app component. So we've got our app that uses the data from the useData hook, and then it's passing it into line chart. But where should we add this extra line? Is it part of line chart? I think it is. I think it is. Yeah, I think we can safely put it in here somewhere. So let's get started by adding an SVG line element. Now, what is this SVG line element? How can we use it? Let's do a Google search for SVG line MDN. MDN is hands down the best. So here's an example line where it's just a line element that has x1, y1, x2, and y2. This is what a line needs to exist. So I'm just going to paste that in here and auto format. So x1 and y1, that's the starting point for the line. And x2 and y2, that's the ending point for the line. So we need to think about where this line should be. It's going to be representing 10,000, so it should be somewhere around here. It's going to be a flat line, like this, a horizontal line, not a vertical line. And horizontal lines start and end at the exact same y position. So I can tell you right now we're going to want to have something called y, or let's be a little more specific and call it marker line y, because y could be anything. I don't want it to get it confused. This maybe ultimately could be its own separate component, a marker line, but let's cross that bridge when we get there. Let's get it working first. So marker line y is going to be used as both y1, and in JSX you need to format it like this, and y2. And then we're going to need marker line x1 and 2. So I'll just fill in these here. Marker line, boom. So now we need to figure out what should these values be. Marker line y, and keep in mind that's going to be representing 10,000 deaths. That was our goal here. So I know the definition is going to involve 10,000, so I'm just going to note it down there. Marker line x1 and x2, that just serves to put the line all the way across the screen. So I can tell you right now, marker line x1 is going to be 0, and marker line x2 is going to be width. And marker line y is not really going to be 1,000. It's going to be 1,000 passed through the scale, because 1,000 is a value in the domain of the scale, namely the extent of the death total. So we just need to pass this through the scale, like this, y scale of 1,000. I think now our line is there, but we just can't see it. So let's try assigning a stroke style to this line and say stroke is black. And there's a line. There's a line there. But it doesn't look to be at the right spot. Oh, that's 1,000. Huh. So 10,000 is there. All right. That looks right. And, you know, now that I think of it, we don't need to add a line for right now, because right now is where it ends. So I styled the path with CSS. Let me just be consistent and do the same for this here. And just so that, you know, in case we end up with more lines, I'm going to give this a class of marker line. And so now in our CSS, I'm going to say dot marker dash line. This is how we can style the marker line. Let's say it has a stroke of black and a stroke width of 5 pixels, or let's try 2 pixels. All right, that looks decent. So this is a pretty good milestone. We have this line chart that shows the coronavirus death total over time and when it crosses 10,000. But if you're looking at this visualization, I mean, if somebody shows you this, you're going to be like, what does this mean? What is this? There's no labels or anything, right? It's pathetic. So that's what we need to focus on next, the labels. But this is sort of a good stopping point. So what I'm going to do is say coronavirus basic line chart with 10,000 marker line. I'm going to fork from this one. And now we can implement the margin convention. Yeah, the margin convention is this whole thing that has some nice visual content around it. Let me just explain the margin convention briefly. There's this canonical work on blocks.org. Oh, now it's in observable. How about that? This is a good diagram that just explains the margin convention, where the origin is here, margin.left is the spacing on the left side, margin.top is the spacing on the top, margin.right is the spacing on the right, and margin.bottom is the spacing on the bottom. So let's go about introducing that margin object. In linechart.js, we can say margin is an object with top 0, right 0, bottom 0, and left 0. And now let's think about, where do we actually need margins here? I think we really need a left margin to pull this content away from the edge to make room for our label. That's this 10,000 label here. So let's give it a non-zero left margin, like let's say 30 pixels. That should be enough for a number. We can tweak it later. And then, down in our SVG element, we can add a new group element around our line and our path. So begin group, end group, and I'll format that. We need to take this group and move it around, meaning transform everything inside this group element by translating it based on the margin, left and top. So we could say in G, transform equals, I'm going to go into ES6 string template literal mode here. The transform equals translate of, I'll just put 0, 0 to explain that the first argument is the translation in the x direction, meaning to the right, and the second one is translation in the vertical direction, meaning down from the top. And so translating to the right, we're going to have to use the left margin. So this should be, and I'm going to break out into JavaScript here, margin.left. This is the magic of ES6 string template literals. You can use this syntax to escape out into JavaScript. So you can actually put any JavaScript expression right in here, which is sweet. And then in the y direction, I'm going to break out again into JavaScript and say the translate in the y direction should be margin.top. Okay, so we've transformed everything there. Now there's a little gap. See that? If I full screen this, you can see that indeed there is a little gap there. But the problem is everything sort of goes off the edge of the screen because relative to this starting point, the scales are still using in their range 0 to width and 0 to height. We need to come up with this new concept of inner width and inner height. Back in this explainer on the margin convention in observable, you see this rectangle, the gray rectangle there? Well, that rectangle has a width of what I would call inner width, and it has a height of what I would call inner height. And how do you get inner width? Well, you got to take the width and subtract the left margin and the right margin. And how do you get inner height? Well, you got to take the height and subtract margin.top and margin.bottom. So let's do that. Back in our code here, the problem is where we're defining range on the scales. This needs to be inner width. And for the y scale, this needs to be inner height. And how do we compute inner width and inner height? Well, like I said, for inner width, you got to take width and then subtract margin dot left and also subtract margin dot right. And for inner height, you got to take the height and subtract margin dot top and margin dot bottom. Now it looks like there's some error happening. Uncaught reference error, width is not defined. Red alert! How and why is width not defined? Well, we're talking about this section here, and it kind of makes sense because width and height are defined only inside the line chart because they're passed in from the outside. Remember in index.js, when we invoke the line chart component, we pass in width and height. And so that needs to be our source of truth for width and height. So I think we just can't define these out here. We need to define them in here and before the scales, because the scales use these. All right, there we go. I think it worked. See that? Boom. And it kind of looks a little weird. Like, sort of goes up against the bottom and the right because we don't have any margins. But hey, that's what margins are for, right? Let's take advantage of our right margin. Let's say right margin is 10 pixels. I would say boom, but I'm noticing a little bug here that the line goes up to the edge still. So I think we need to take this into account in our line component as well. Yeah, there it is. Marker line x2 actually should be inner width. That's that. Boom! Now I can say it. Boom. See? We've got a right margin. And just for good measure, I suppose, let's add a little bit on the top and a little bit on the bottom. All right, now, somebody there? Okay, yeah, they still look uncomfortably close to the edge, and I can totally understand that. So let's do something cool that you can do in VizHub, which is in Vim mode, if you hit Shift V and then colon S slash, I can replace all those 10s with 20s slash G. So that's S slash 10 slash 20 slash G. This is a Vim mode regular expression thingamajig that makes a replacement. So if you hit enter, boom. Now the margins are all 20. A little bit more? Maybe 40. And yeah, it's a little, it's more breathable. It has more white space. I like that. But this space on the left doesn't actually look like it's enough for text. So let me make that like, I don't know, 300? That's too much. What about 90? Yeah, I could imagine a little 1,000 being right there, or 10,000 being right there. But this is a pretty good milestone. I mean, I just want to say, that's how you do the margin convention. That's all you need to do. Just to recap the margin convention, you define a margin object with top, right, bottom, and left, and then you need to compute inner width and inner height, and then use those in the scales, and whatever thing that you are using that needs to go all the way across that inner rectangle. So this is a pretty good milestone. Now we're in a position to add this label, 10,000. So how do we do that? Well, in SVG, you can use a text element. So text, or I think it has to be like this, open text, close text, and then I'll just say 10,000. And, oh, there it is. It says 10,000 right there. But it's not lined up to anything. It's not aligned. And so the text alignment is what we need to work on now. What I'm thinking is it shares a lot of similarities with marker line, because marker line x1 and marker line y is this point right here. And I think that's where we need to start. So in SVG text, you can give it x and y. So x, I think, should be marker line x1, and y, I think, should be marker line y. Okay, now it's aligned. See that? But it's aligned with respect to the bottom left corner of the text. And that's where it's sort of problematic for us, because I want to align this to the right center. But I think we can do that. I have to just research a little bit about SVG text. Vertical align and horizontal align. Yeah, there's alignment baseline, and then there's, how do you do horizontal align? It's text anchor. Yeah, it's these two like super weirdly named things. But yeah, text anchor is what you need for vertical. So let's try that. And I believe that can be an attribute. Yeah, like this, not a style. So it can look just like that. If we go over here, in the text, we can say text anchor equals middle. And there's a little gotcha here with React. I don't think React likes these dashes. I think we might need to do it like that. Although, wait a minute. That actually worked. Oh, so maybe that's fine. Okay, so that's our horizontal alignment. Before we go any further, I kind of want to just make it a little bigger. So in our CSS, we can say text, all text elements shall be font size, I don't know, 16 pixels, let's say. That's pretty, I think that's the default. That's pretty darn small. How about 64? 2EM? Yeah, we can use EM here, totally. Yeah, 2EM looks great. That's about the size I was imagining right there. And with fonts nowadays, I've been having a predisposition toward using the open font stack, or the, what's it called? The system font stack that comes with Create React app. So let me just take a little detour to get the font right, because I want to get the font right on this. If I open up a terminal, I'm going to make a new directory, CRA testing, and then I'm just going to execute Create React app. And, oh man, hold on. So Create React app is this amazing boilerplate for starting a React application in your own local development environment. And they have this amazing... Oh, I didn't run Create React app yet. Oh, I'm getting some text distortions. That's weird. Are you all seeing that text distortion? The image distortion there?
Yes.
So if you run Create React app, you got to give it a name. I'll just call it testing. And then it's going to run all this stuff and set up a React app. And it includes a really nice little snippet about setting the font on everything to be a nice system font stack. And so I'm running this just so I can grab that out of there and use that in VizHub. And by the way, anything you do in VizHub, you can just export the files, move them into an application that uses Create React app, which is very popular nowadays. And everything should just work because it uses ES6 imports like that. All right, so in this Create React app, very fresh thing, in source app.css, or no, in source index.css, here it is, font family. This is a really cool font family. It uses whatever font is built into the operating system of the viewer. So they've went and picked, the best fonts that are available, so you don't need to pull in any fonts from like Google Fonts or anything, but yet you get really good looking text. So that's what I'm after here. So I can take that and paste it right here in VizHub and apply it to the body. And now the font has changed on our 10,000, and I believe it's using Ubuntu because I'm on Linux. And so that's a really nice looking font, better than whatever was showing before, which is just the default. I don't even know what it is. But anyway, now we have a nice crisp, nice looking 10,000. We just need to align it correctly. So the alignment we've done so far, we said text anchor is middle. But text anchor, doesn't have to be middle, and I don't think we want it to be middle. It could be start, which I think is the default. See that alignment? It's aligned to the lower left. But it could also be end. That aligns it to the lower right. So this is what I'm looking for. Now I want to align it vertically to be in the center of this line, which it's not. It's currently above it. So that would be alignment baseline. Alignment baseline attribute specifies how an object is aligned with respect to its parent. So this is something that you can use with SVG text elements. Here's a really nice visual example of this, where alignment baseline is hanging, and they have the little visual here. So it's hanging from the bottom. It's like an icicle or something hanging down. And then the middle is in the middle. That's what we want. And we want we don't want baseline, which is the default, which is what it's doing now. So let's just copy this. Alignment baseline is middle. And then in our code here, we can apply that to our SVG text element. And now the labeling is pretty much how I wanted it to be. But it's getting cut off, so it looks like we need to go back and tweak the margin, specifically the left margin. Let's try 120. That looks decent, but let's let it breathe a little. How about 150? Or 160? I don't know. It's personal preference. It's a design thing. I don't know how to put, how to decide how much white space to put. But it's a little too close to that line. See that? It's very close to that line. I want to add a little bit of white space. Let's see how we could do that. I think we can just tweak the definition of this text element to get it done. For example, on y, see here, this is the line that defines y, which is the vertical direction, and x, which is horizontal. And so if we just subtract a little bit, like 5 pixels, then it adds a little 5 pixel gap. Easy peasy. Or 50 if you want to move it really far away. But I just wanted a little gap, maybe 8. Yeah, that's pretty cool. Yeah, I think this is a pretty effective visualization. But now that I see it like this, you know, I kind of do want to add the marker for now, just to make it explicit. I think I'm just going to go ahead and add that other line for right now. It's going to be a vertical line on the right, and it's going to come down, it's going to say now. Just like this says 10,000, it's going to say now. I think this would be an effective, simple visualization without the axes. You know, that you could show people, and you know, they would understand the relative scales of everything. You know, this is like saying to somebody, you know, the death toll crossed 10,000 2 days ago, which is what happened. But this tells you how much it climbed. That is an exponential curve and so on. So I think that's what I'm going to do next. Well, I'm going to write the code that I want to see. I want to see y marker line, and we pass into their, or value, let's pass into their value would be 10,000. And then y marker line should be able to take care of the rest. So let me just define that right here. And then we'll be able to make an x marker line, see how they're different. Yeah, I think this is the right approach. So I'll say const y marker line, a function that returns, and this is where I could just move all this logic into here. And these definitions can go inside. And then this is what we want to return, this JSX. Oh yeah, now we're getting this error. Oh, my favorite error. I love this one. Adjacent JSX elements must be wrapped in an enclosing tag. You know what that means? We have to use a React fragment like this. Boom, boom, to open it and to close it. Boom, boom, boom. Now the auto format should work, and all is well again with the world. Okay, and even our code is working. That's great. So, what did we pass in to y marker line? We passed in value is 10, that should be 10,000. Value is 10,000. And so in the definition, we need to unpack value like that from the props and then pass it into y scale like this. And if we wanted to, well, I do want to split this out into a separate file, because this file is getting pretty long, almost 60 lines. So, and this is a good thing to just split out. So I'm going to make a new file, ymarkerline.js, and then I'll take all of this and put it in that file and export it. And then in line chart, we can import ymarkerline from /ymarkerline. And we might get some errors. Y scale is not defined. Yeah, I think there's some things that we need to pass in that we're not passing in. So what does y marker line need to know about? Apparently y scale, yeah, it needs to know the y scale because it's being passed through. And it also needs value. Yeah, let's just pass in y scale. I think that's the simplest way to do it. So if we accept y scale there, we need to pass it in here. Y scale is y scale. And what else? Oh my gosh! It works! Alright, so that's how you can refactor that y marker line out into a separate module so your line chart component is not getting overwhelmed with that logic. And now we can just copy paste that and change y to x and the value to be now. But not exactly now. And this is probably going to need to know about x scale. So when it comes to this now, where do we get this from? Well, we have it in useData, remember? And now that I'm remembering how the data is structured, the last element in that data array is going to be essentially now. It's going to be the most recent data point. So let's isolate that. We can isolate that right here, I think. It's going to be data at data.length -1. Let me just console.log that to see what it is. Uh-oh. Reference error, X marker line is not defined. Well, that makes sense. We haven't defined it. So I'm just going to comment out this line for now. Let's work out this other piece and then get back to that. Okay, we're getting undefined because I misspelled length. So we need to access .date on this object. So the last data point, .date. This is going to be now, or most recent date. Wait a minute, we already have it as the extent of the xscale domain. So that might be actually a more elegant way to get at it. Yeah, xscale.domain at index 1 should be the same thing, and it is. So what should we call this? I'm going to call it most recent date. And so the value that we want to pass in to x marker line, which we can define now, is going to be most recent date. And now let's go ahead and define that. I'm going to do the import first, replace x with y, and then I'm going to make a new file called x marker line, and then I'm going to copy paste everything from y marker line into x marker line, and then modify it as needed. So let's export the renamed version. So now our component runs, but we have the error y scale is not a function. That makes sense because now we're passing in x scale instead. And so marker line, well, now is because it's going the other direction, we're going to have marker line x and then marker line y1 and then marker line y2. Marker line x is going to be x scale of the value. Marker line y1 is going to be 0, and marker line y2 is going to be inner height. And we need to define that. Yeah, we need to pass in inner height from line chart. Inner height equals inner height. And I was noticing for y marker line, it's referencing inner width, and I'm confused as to why that's working because we didn't pass it in. So let me just fix that. We should be passing in inner width as a prop to y marker line. So y marker line needs inner width equals inner width. Anyway, we're in a broken state. Let's get out of that broken state and see what else needs to be changed. Yeah, we just need to go through and pass in the right stuff. So y1 is going to be y. So now in x marker line x needs to be 1 and x2. Y needs to be changed to y1. Y2 needs to be changed to y2. And the text also is going to be in a different spot. Okay, we got it working to some degree. All right, this is great, this is great, this is great. All I want to do now is move this text label to the bottom and have it centrally aligned with respect to this line and have probably the same gap that we have over here, but vertical instead of horizontal. So we got our friends here, text anchor and alignment baseline. I think text anchor can be middle. Yep, see now it's in the middle, that's good. And alignment baseline can be hanging. Yeah, see that? Now, instead of using y1, if we just use y2, it should go to the bottom. And then, instead of subtracting 8 from x, let's add 8 to y. Now we get that nice white space, and all we need to do to wrap this up is go back and change the margins. Namely, the right margin needs to be more because it's going off the right edge. Let's say 100. Or that might be too much, maybe 80. Yeah, it's showing the wrong text. I'm just getting the alignment right. Yes, that's a very good point. So it should not be saying 10,000. Instead, it should be saying now. There we go. And I'm realizing now that, the label is hard-coded in this component, which is not ideal, but probably it's fine to just leave it for now. if we need to generalize these further, we can do this. We'd have to get into the formatting and everything. Yeah, I mean, we could add another pair of these for 1,000. Like, when did it reach 1,000 deaths? I'd be curious actually to see that.
We should do X and Y axis.
Oh yeah, we've got to add the axes and the tick marks. Tick marks are cool to have, for sure. All right, so this is what I wanted to get to. This is a pretty good milestone. We got right now, and over there we got 10,000. Sweet! See that? That's how you can do it. Start with an idea and just keep going until it's done. That thing's not focusing. Focus. Here we go. We've implemented most of this sketch. The only remaining things are the axes, like Nita was saying.
It looks exactly similar to your scale.
Doesn't it?
How did you do that?
I just sort of knew this is how it would look.
Nice.
So since I drew these X tick marks first, let's go for that. Let's try to add the x-axis. All right, now that we've got this line, we've got the 10,000 marker, and we got the now marker, I think I would like to add in full-on axes, like all-out axes, using D3 axis. Now, this is going to require a rather interesting integration with React and D3, using refs, references, React refs, and React hooks to actually use D3 to do the DOM manipulation within certain group elements. So here's the strategy for this. We introduce React components that just create SVG group elements. And inside of those components, we can get access to the underlying DOM element after React has rendered it inside useEffect using refs. And then we can invoke D3 axis to just do the DOM manipulation for our axis. So let's do it. Let's get to it. I'm going to start by forking this. And then just to set my intention, I'm going to change the title with D3 axes. Or this is going to be more of a technical focus, so I'm going to say React plus D3 axes. So the question arises, who owns the axes? Is it index.js? Is it our app component? Is it our line chart component? I think it's our line chart component. But just like X marker line and Y marker line, X-axis and Y-axis could be a pretty good split for different components rather than putting everything in the line chart component. So let me sketch out what that might look like. Before our path, or after, it doesn't really matter, we could put X-axis. And it's going to need to know about certain things. Definitely it's going to need to know about the X scale. So I'll just go ahead and put that in first. And I think that's all it needs to know about for the time being, just to get started. And I know I'm going to want it in a separate file, so I'm just going to start with it in a separate file. I'm going to call it xaxis.js. And we can pull in x-axis from ./x-axis. And we're getting an error. X-axis is not exported by xaxis.js. So let's fix that. Let's say export const x-axis is going to be a function, particularly a React component, that takes as input a prop of x scale for sure. Okay, I know we're going to need that. And it's going to return a humble SVG group element. Now, this SVG group element is special because we're going to make it a ref. This means that we can get access to the actual DOM element, not this virtual DOM, the actual DOM element that we can pass into D3 to let D3 do the DOM manipulation to add the axis. The way that we do that is use refs. In the React Hooks API reference, there's a link to useRef. This is the hook that we need to use here. we just call useRef. And then when we're rendering our elements, we just say ref equals that ref. Ref is a special prop that all of these React elements can accept. And if you set it up like this, after it renders, it's going to assign this ref.current to be the actual DOM node that you can pass into D3. Well, let's just take a quick look through this example in their documentation. useRef returns a mutable ref object whose .current property is initialized to the passed argument. We don't need to use the passed argument. And here's a common use case. For example, a text input with a focus button. If you click on this button, it'll invoke this function which calls inputl.current.focus. And .focus is a method on DOM elements. It's a DOM API, from the document object model API that's built into the browsers without any library. .focus is there. And so inputl.current is the actual DOM node for this input element after it's been rendered by React. And inputl is useRef. And they're passing in null just to give it a default value of null, which doesn't really matter. So that's an overview of useRef. Let's use this sample code to get started using this in our code. Now, remember why we need to use useRef. This group element is something that we need to get access to its raw DOM element to pass into D3 axes. So this is where we need to set ref equal to, I'm just going to call it ref, because there's only going to be one of them. And ref is, I'm going to paste that sample code. Ref is useRef. I'm not going to pass anything. And now, oh, wait a minute. I think there's an error. Yeah, useRef is not defined because I didn't import it. Import useRef from React. OK, now it's working. Now that we have this ref, we can use the useEffect hook to get access to it, like this. useEffect. And this is another thing we're going to have to import from React. So I'll do it now. Now, useEffect takes as input two arguments. The first argument being a function, and the second argument being an array of dependencies. And always remember, if you don't specify that array of dependencies, it's going to run every time the component renders, which we don't want, I don't think. Let me think about that. I don't think we want that. In this case, it's just a static visualization, so it doesn't really matter. We can just do it once and we'll be good. So this is how we do it. Inside of useEffect, we can access ref.current. This will give us the actual SVG group DOM element. And that is what we can pass into select from D3 select. And this is what I would traditionally name x-axis G, because it's the x-axis group element. And for this to work, we need to import select from D3. It runs just to verify that it's doing what I think it's doing. I'm going to say console.log x-axis G. And it gives us something that looks like a minified variable name, but has groups and parents. Yeah, this looks like a D3 selection. All right, that's how you can do it. That's how you can use D3 selection with React refs. Now, what we need to do is render the axes in here. So let's look at some example of D3 axes. The D3 axes package is what we need here. And here's how you use it. D3.axis left, or axis top, or axis bottom, or axis right, I think. But who puts axes on the right? What we want here is axis bottom. So in our code here, we can import axis bottom from D3, and then we can define x-axis to be axis bottom. And I believe, if I recall correctly, you can pass in the scale just like that. But let me check the documentation just to Yeah, that's totally how it is. See, d3.axis left, scale. And then to render it, see, this is how you would render it with d3, .call axis. And so what we've got in our code here is essentially the same thing as what would result from all this code, but we got it through React. React is managing the parent group element. So we could just say x-axis g.call axis. So let's try that. X-axis g.call x-axis. And lo and behold, it worked. Oh my gosh, look at that. It's on the top, which is not where I want it to be, but that's not too hard to solve. How we usually do it with D3, and we can just carry that over to React, is we say, on this group element, the transform is translate. We want to translate this down. So 0 in the x direction, and in the y direction, that should be inner height. I'm pretty sure. Yep, that should be inner height. Yeah, so the thing is, we don't have inner height here. So let me accept inner height as a prop. And then over in our linechart.js, we pass in inner height to the x-axis like this. Inner height equals inner height. OK, that worked. That worked. Our axis is now on the bottom. We're left with some styling issues. So let's see how these are typically resolved. I think these are typically resolved just through CSS. I could try to find some example, but I think I can just, poke around in here and figure out how to turn things on and off. So if I just inspect this element, we can see this DOM structure that D3 has generated inside of our axis. One thing that I just don't want to see is the domain path. Yeah, the domain path, if you just delete that element, it gets rid of that line. So we can style this with CSS. If we just, in our CSS, we can say .domain to select that domain path. We could say display as none. And now we need to think about, what do we really want our axis to look like? One thing I think would be really cool is to have these lines going all the way across and then make them like a muted color. So let me try that. I believe there's something we can tweak about axis bottom to make them go all the way across. I think it might be tick size. Let me try tick size. Yeah, I think that's it. See, tick size is 20. It makes these go down like that. And so if I say minus 20, the ticks go up into that inner rectangle of the visualization. And so now we've got inner height and scope here, so we can say inner height. Yeah, so these are the tick lines, which I kind of want to style them in a more muted way. They're really intense right now. Let's take a look at these elements again to see how we can access them from CSS. See, all these group elements have a class of tick, and that tick includes the line and the text elements, but we can use this to our advantage and say .tick space line is the selector we need here. So .tick space line. The lines of the ticks, their stroke should be, let's say, red, just to see if it works. OK, they're red. Great. Now, let me see if I can use the Chrome DevTools to pull up the color picker for these. And indeed, it works. See that? Yeah, this is a cool trick that you can try sometime. Just open up the Chrome DevTools, go to the styles, and you can change the color in real time. But it doesn't persist to the code. So once you find a color you like, I kind of like this color right here. I'll just copy this hex string out of here and then go back into the code and use that as our color. Very good. That looks pretty decent. I kind of want to make these a little farther away from the bottom. Let's see how we can do that. I think there's a way to do it in D3 axes, but I don't remember what it is. Ah, tick padding. I think it's tick padding. Let's give it a try. So if we append here tick padding, is, let's say, 20. Okay, that adds some nice space below our ticks. See, that's that white space there. I kind of want to make it match up with that now text. And I kind of want to make these labels a little smaller. And then I think we'll be pretty much done with the segment. So Alt-P to use prettier to format. And let's set the tick padding to 18. That looks pretty good. And now let's make these labels a little smaller. And we can do that by saying tick text. Same selector, but instead of the line, the text. For this, the fill, I think, is what we need to change. Make it red to just test if it's working. Okay, it is working. Yeah, that can be a little muted as well, but not quite as muted as that one. Let me go back in here and get that color picker back and pick a darker tone. Yeah, that's a good one. And now let's make the font size a little smaller. I like EM because 1 EM is what it is now. It's like the default. Or, wait a minute, something's wrong here. Oh, I remember. With axes, there's something strange about the EM unit. So probably best if we just avoid it. What if we say 16 pixels? Yeah, how about like 14 pixels? That looks pretty good. All right, there we have it. That's how you can add a D3 axis, a real D3 axis, where D3 is doing the DOM manipulation, into a React component using the useRef hook and the useEffect hook. And you can use some CSS to style it as you would if it were rendered in D3. All right, thanks for watching. Welcome to the second installment of our coronavirus hackathon. Last weekend, we did this, made this line chart. And let me just review the code real quick, just for those who missed it. We're using VizHub, this platform that I am working on. And here we can use React and ES6 modules. So we've got this app component that loads the Johns Hopkins coronavirus dataset with used data. And you know, during this past week, this link actually broke. This URL broke because they changed the format. And so I put it back to the link with a fixed commit, so it's not going to break, but it's also not going to update over time. So one thing I'd like to do today is to bring back the live link, and we're going to have to adapt to some changes that they made on their side with regard to the structure of the data. So this loads in that data, and then there's this line chart element or component that renders the data as a line chart. And it's pretty standard D3 plus React line chart, where D3 does the calculations and React does the DOM manipulation. So from here, what I'd like to do is make it closer to that scatter plot by John Byrne Murdoch, which I'll bring up real quick. This scatter plot I think is amazing because of the way that it puts this coronavirus data in perspective. It's got a log scale on the y direction, which sort of flattens out the lines. They don't look exponential like they do in the one that I made. And it normalizes everything to start at the 10th death, the date of the 10th death. So to get closer and closer to this, here's what I'm thinking of doing today. First, we add the y-axis, meaning the y-axis ticks and those lines. And then we'll be seeing just a summary line for the whole world, which is what I'm showing now. And then we can break it down like this and show different countries. And so we should get something very similar to this scatter plot and see where we can take it from there. So back in VizHub, I'm going to start by forking this one because I want to preserve this old one. I'll fork this. And then to set my intention, I'm going to rename it to coronavirus log scale. Because that's really all I plan to do for this iteration, is to add the y tick marks and then to make it a log scale. See how it looks. So we added the x-axis last time. Let's do the same for the y-axis. And the way we do that is I'm just going to make a new file and call it y-axis.js. And I'm just going to copy paste everything from x-axis into y-axis and change things as needed. So what do we want to do here? This should be a y-axis, so I'm going to change x to y. And then instead of x scale, it's going to be y scale. And remember why we needed inner height for the x-axis? It was to bring it down to the bottom. It was this translate right here. And we don't need to do that for y. So I think I'll just get rid of that inner height. And I'll get rid of this code that uses it. Yeah, we don't need that transform anymore. The React ref we still need. And then, yeah, because we're using it to populate a D3 selection to let D3 do the DOM manipulation. Yeah, this is a really cool type of integration with React and D3. So I'm going to change all these x to y's. And instead of axis bottom, this should be axis left. So I'll change that import as well. And then when we define y-axis, we need to pass in the y scale. And tick size is the thing that makes the tick go all the way across. And so now that I think of it, we are going to need to know about inner width. Because imagine if we do these grid lines, which I would like to do, for the y-axis, they're going to have to go from left to right, and that is inner width. So I'm going to add that as a prop. And the tick size is going to be minus inner width. And oh, this was just some custom stuff I did in the middle of the week to make sure that the label doesn't overlap this big label here. So I'm just going to remove that. It just removes the last tick. But we need this part here. So yeah, this part here, xssg.call, x-axis, we need, but removing the last one, we don't need. So I'm going to delete that, replace these x's with y's. So now we can go back to linechart.js, and in here, in addition to this x-axis, we can add a y-axis and just change these x's to y's and change inner height to inner width. And this is where it should be working, but there looks like there's some error. So the error is y-axis is not defined. Right. I need to import it. And then we import the x's to y's. And boom, it works. See that? All right, we have added tick marks to the y-axis. Pretty straightforward. So where do we want to go next with this? My gut feeling right now is I kind of want to get rid of these labels that we added earlier, because now that we have these axes, they're not really required. So that's what I'll do next. I'm just going to get rid of x and y marker line, and then when we use them in the code, oops, I can just get rid of this code here that references those. And now the marker lines are gone. And in the x-axis, I added some custom logic to get rid of the last tick, so I'm just going to get rid of that. Okay, there we go. Now we've got all the ticks. All the ticks. So, you know, this is a good breaking point. I'm going to call this the coronavirus, or this is a coronavirus linear y-axis. And I'm going to fork this. So from the coronavirus linear y-axis, I'll fork this and then change the title to log y-axis. And then when we create our y-scale, this is how you can change linear to log. Just change from scale linear to scale log. And we need to import our scale log from D3. And I think that should work, but it looks like it's not working. Let's see why. Okay, we're getting not a numbers in our path. That suggests to me that we have like divide by 0 or something, or trying to take the log of 0. So the trick with log scales is you can't start at 0 with the domain. So it's sort of silly, but let's start at 1. Okay, we get this new visualization here, which is kind of interesting. these labels are not quite right. This is sort of what you get out of the box with D3 axes. Well, let's see if we can address these labels. So in y-axis is where these labels are getting set up, and it looks like it's just using some default tick format. So if we use tick format, we can specify a function that takes as input one of those tick values, and let's just return tick value. Okay, so now that we're specifying tick format, we're getting labels on everything. But I'm really only interested in like 10, 100, 1,000, or maybe we could put 2 and 5 in there. This is kind of a tricky one. This is where I might want to stop and research what others have done with regard to D3 log scale ticks. Oh, the first thing I see is scale.ticks in observable. Okay, so getting the ticks on a log scale. See, if I do log scale, I don't know, it looks like it should work. So let me give that a try. So the idea is, I wonder, is that going to give us the nice collection of tick marks that we got out of the box? See, just to remind you, if we don't specify the tick format, it gives us a limited number of ticks. So I wonder, if we do console.log yscale.ticks, what do we get? Okay, we get all of them. That's the thing. So we want to like filter out. I don't know how to filter out these ticks. You know, this is a problem that I solved once like years ago, but I don't remember how I did it. Yeah, I'm looking at Stack Overflow. We could specify the tick values. I don't know. Let's see what they've got in observable. Oh, interesting. So I'm reading through these and I noticed here's this one. If we say ticks 10. Oh, there's something new. Okay, D3 changed on us. As with linear and power scales, you can control tick formatting with a second argument to .ticks. So let me try this approach. Yeah, it used to be different than this. Let me try this and see if it works. So this avenue is not going to work. This avenue I don't think is going to work. I'm going to comment that out. And then I'll paste that thing that I found in observable .ticks with S, and boom! Boomski woomski. You see that? These look like pretty good tick marks. Yeah, okay, great. So this is pretty much where I wanted to get to, but let me just do some minor tweaks like the spacing. They seem like quite far away from these lines, and maybe tweak the margins. Just do a little bit of tweaking here. So in line chart, we can easily tweak the margins. Like the bottom seems to be, we don't need that much. And on the right, we don't need that much. On the left. And now I want to look at the spacing between the lines and those numbers. I think that's a property of the axis itself. Yeah, that's tick padding, I believe. So what if I bring that down? Yeah, I'll make it really small, like 3 pixels away. Yeah, now you can really get a feel for, okay, this number is for this line, the top line. It's kind of cool how there's more lines than labels. There's some magic going on inside D3 that's doing that, I think. Pretty cool. Okay, so this is the log scale trajectory of coronavirus deaths. But you wouldn't know that just looking at this chart. You know, I mean, maybe we should add a label to the chart itself. So where should we put it? Should we put it on the top or put it on the left? Okay, we need all 3. So we need a title on the top, we need a y-axis label, and we need an x-axis label. So I'm going to fork again from here, because this is a pretty good state to keep it at. Okay, now I'm going to set my intention by changing the title to, well, the focus is really going to be on labels, visualization labels. So I'm thinking a logical place to put it would be in the axes components. Let's just start with the x-axis. So inside this group element, we could actually put a text element. That's what I'm going to do. I'm going to break open this, or wait a minute. That would cause a problem because D3 is managing the DOM within this group element. Yeah, so I'm going to backtrack. Yeah, that would not work because then React would be trying to put stuff in that group element. D3 would be trying to put stuff in that group element. It would be a mess. So maybe we should put those labels right in linechart.js. Yeah, this looks like a good spot. And so SVG text is there. This is showing coronavirus deaths, global deaths for that matter. Hey, look at that, it's done. Ha ha ha. That's not bad actually. Let's tweak that wording a little. I'll say overtime. Okay, so we've got the label for the whole visualization. Now let's add smaller labels perhaps for the x-axis and y-axis. So let's try for the y-axis first. This would be deaths. And we want to rotate that. So I'm thinking we want to rotate that text by 90 degrees and then put it on the side. So let's try rotating it. And we can do that by setting the transform to be, by the way, transform is a super cool domain-specific language of SVG, and you can put a lot of stuff in there. So I think we've used transform translate to move around the group element like this. But you can also have space-delimited things in there, one of which is rotate. So let's try adding rotate 90. Let's see what happens. Okay, that worked, but it's pointing downward. I want it to be pointing upward. So let's try inverting that, maybe minus 90. Okay, great, now it's going upwards. I think what I want to do is center the label vertically. Yeah, and to do that, again, I need to research about what this is. SVG, horizontal and vertical align. Oh yeah, text anchor and alignment baseline. My old friends. So let's try text anchor. And we set that to be middle, I think. There we go. So now the label is correctly positioned vertically with respect to the point where it is, which is not where we want it to be. We want it to be down. And so to move it down, we can actually just put that inside this transform. We can say translate space rotate, and you can have translate and rotate both. And so I think there's a syntax error here. Let me just put 0, 0 to start. See, I don't know which one comes first, really, rotate or translate, so I just have to guess. So if I put 50 here, see, it moved to the right. That's not what I want. I want to move down. So if I put 50 here, it goes down. Perfect, perfect. So yeah, the world is still sane. The first argument is x, the second argument is y. We want this to go down by, well, we want it centered here. So we really need to move it down by inner height divided by 2. So these deaths, I mean this label that says deaths, should be vertically centered. And so we need to set the y translate of this to be inner height divided by 2. And there we go. There we go. And I'll auto-format that again. That looks to be in the right space vertically. Now we just need to move it over to the left. And can anybody do that? Now, I'm going to demo a brand new feature of VizHub. I'm going to drop this link here in our Slack. So here's the thing that I'm working on for all of you following in Zoom. So you should be able to open this link and check this out. In here, I'm going to go click on this share button and go to collaborators and say anyone can edit. This is a new feature of VizHub that's just was working starting yesterday. So what I want you to do is modify this code to move this deaths label to the left. And I'll give you a hint. It's somewhere in here. is where you should change. So I'm just going to sit back and wait for somebody. Anybody, feel free to make that change. Hey, somebody did it! Woohoo! Yeah! This is so cool. Nice. Okay, so you changed it to be minus 30 right here.
I would like to change the left a little bit. Would you mind it?
Go ahead. Yeah, you have to change the left margin. That's fine. There we go. Nice. Nice. Oh man, this is so cool. This is so cool. First time somebody's remotely editing my thing on VizHub. I think this really opens up a lot of possibilities. So while you're at it with the left margin, I'm going to adjust the translate again because I think it's a little close. Oh, you're editing it.
Oh.
Let's make it 35.
Okay.
Or maybe 40. And you know, I should be clear that this is not just deaths, but this is cumulative deaths. And I don't know, I don't think we need to add a label that says time, because when you see dates down there, it's kind of self-explanatory. What do you think? Oh, nice. You getting started on it? I think you put text anchor middle on the title at the top. Oh, this is so cool. Let's just add time while we're at it. So I made a new thing down at the bottom, and for that text anchor should be middle, and this is just going to say time. And this should be going down to the bottom, and so we can do transform translate by inner height, and we don't need the rotate. Cool. So the first text element I'm going to, so I think that's the one you're editing. Could you just get rid of that transform? Put it back to the way it was? Or actually, that looks decent. That looks decent in the middle. Yeah, so for the topmost label, I'm just gonna, or actually, I see you're editing that. What is your idea there?
It should be in the middle, right?
Ah, in the middle.
Divided by 2.
Ah, yes. It's actually, you're halfway there. That's actually correct. I'm going to make a change there and add text anchor middle, and that should do the trick. There we go.
I thought so.
Yeah.
Good.
So now I'm going to work on the time thing. The time should also be translated by, that I also want that to be in the middle horizontally. So that should also be translated by inner width divided by 2. All right, and we can move it down a little bit by just adding something to inner height. Let's say add 8. Or you know what? I want it to be relative to the top of the text. And so this text here, the position is relative to its baseline. See that? That bottom of the T right there, that's called the baseline of the text. And so I want the baseline alignment to be hanging, meaning the top of the T should be hanging down from there, and then whatever we add will be the number of pixels it is away from that bottom line, which is how I'd like to define it. That way we can change the font size and the relative positions of everything would remain consistent. So for that, we can say alignment baseline equals, I think hanging. Yeah, see that? It works. And by the way, all this stuff is documented very nicely in MDN. Yeah, it's a part of SVG. These are the possible values. All right, so as I was saying, once we set the alignment baseline, we can add something to Y to make this go down. And so that's where we can say inner height plus, let's say, 20. Yeah, see, now it moved downwards. And we can move it a little further, like, I don't know, 40? Yeah, that looks decent. And then we can go back and tweak the margin, the bottom margin, to be like 90 or 80. And you know, I kind of want to make these labels a little smaller than this one, and maybe a little fainter, not quite exactly black. to do that, perhaps the cleanest way would be to assign a class to these text elements here, like axis label, and then use CSS to do this styling. And in React, you have to say class name. Careful. Class name equals axis dash label, and the same for that other one. And then over in our CSS, so we were going to try to change the style of this label here and this label here, because I kind of want to just make them a little smaller and maybe a little bit faded out. And so we added the class to them called axis-label. And by the way, it's helpful to inspect the elements with the Chrome DevTools. That way you can see, okay, definitely, there it is. Class equals axis-label. All right. So what we can do is use these DevTools to figure out what style it should be. And so we could say color is, let's say, red. That didn't work because it's SVG, and we need to say fill is red. There we go. Now it's red. See? There it is. So we can use the Chrome DevTools to pick what color we want. I like the grayscale approach. That color looks decent to me. And so once you find a color you like, you can... Whoop, my face is in the way. You can copy it to the clipboard and paste it into your code. So back in the code, in our CSS, I'm going to say fill is, and then paste that color. And then we need to figure out the selector, which is going to be axis-label. And that should work. Okay, great. See, it worked. Now both of them are sort of grayed out, and let's just make them a little smaller. We can set the font size to be, well, 14 is what the tick marks are. I think we can make it bigger than that. Let's make it, I don't know, 18 px, or how about 24? Okay, but anyway, that just gives you a sense of how you can style these labels with CSS. And you can tweak that to your heart's content. Get a designer to work on it. All right, so we've added some labels to our visualization for the title, for the x-axis, for the y-axis. And we're showing this line of cumulative deaths for the whole world. But what I would like to do is split this line into its constituent parts. And doing this, we might need to upgrade to the new data format from Johns Hopkins. Yeah, that's what I want to do. That's what I want to do. See, it's pulling from this old data set. And let's see how we can pull the live data set. Yeah, see, this is essentially what our visualization is pulling for. It's a page that has moved or been renamed. So let's see what happened here. So this is the Johns Hopkins data set. And the time series is what I was interested in. And see, there's a deprecation warning. These files, the ones we were using, will no longer be updated. With the release of the new data structure, we are updating our time series table to reflect these changes. Please reference confirmed global. Yeah, that kind of makes sense. This is a good read. Upcoming changes in time series tables. The upshot is 3 new time series tables will be added for the US. At the county level. This is epic. So I want to make this line chart for all the US counties, but first let's do it for the countries because that's already been done and we sort of know what to expect. The tables will be renamed time series COVID-19 confirmed global at the end. So I think that's all we need to do is update the file name that we're referencing. Let's just take a look at the file itself. It's got the same breakdown it did before, province, state, country, region. But let me see for the US. For the US, it does not have states, I don't think. I'm trying to find US. Where's the enter for US? There it is. Okay, so now this data set has changed. Before, it was all the states had their own entry. Now the US as a whole has one entry in this table. And other places have like a breakdown. And so if we visualize this data directly, which we're going to do first, is then we're going to see a line for Bermuda, a line for Cayman Islands, a line for Gibraltar. But ideally, I would like to just see a line for the United Kingdom. Hey, check this out. There's a summary column for United Kingdom. Oh. So I think we're going to actually need to... One thing we can do to solve this is filter out all the rows that have anything present for the more detailed area. Yeah, I think that's what we're going to need to do. Let's get at the raw URL for this. So if I click raw, I get this URL here, which I'm going to paste in our code. Before I do that, I'm going to fork this just so I don't break this and rename it to pulling live coronavirus data. So in useData.js, we've got these different CSV URLs. The one that's being used right now is for a fixed commit, so I'm going to comment that out and then uncomment the one that we had before for pulling the live data, and I'm going to paste the new URL here, and see the only difference is in the end of the file name. So I'm just going to paste in this string itself that URL, get rid of that comment, and hopefully it should work. All right, look at that. Great. Aha! It's working. So this is now up to date. This is going up to, well, I wish I could say by looking at it. I don't know exactly. March something, March 20 something. So that's good. That's how we can pull the live data. So I'll fork that as well. Why not? Because now we're going to start working on lines for each country, or how should I put this? Coronavirus deaths over time by country. Yeah, by country. And so we've got the title there at the top. Let me just update that as well. Over time by country. And then we have to go into this data file, this useData thing that we've got. Oh, before we move on, I want to get this URL that will not break, that shows us this view that we're looking at right now. So just before we move on, I need to get that sorted out. So I'm going to delete that. Go over to this page here. Go to the latest commit, this one here, and then go to Browse Files, COVID-19 Data, Time Series, Deaths Global, Raw, and this time the URL has a commit in it. And so I can copy this to get this URL that's never going to break. And so if tomorrow I look at this and it's broken, I can just uncomment this line and everything should work. So let me just test that it works now. Okay, it's working now with that commit. And so, in case this breaks, I can resurrect it by uncommenting that. Great. So let's consider that we want one line for each country. The first good place to get to would be just a console.log that prints out all the countries for us. And by the way, here's where we are doing our aggregation. We're just summing up across all the rows, the total. So in the very beginning here, we can say console.log raw data. And this is what we see, this array where there are objects, each of which has values for all these days. And it's got a country/region and a province/state. So what we want to do is filter out all of these that have anything that's not an empty string for province/state. So I'll say const, I'll call it countries data equals raw data dot filter. a function that takes as input D, one of the rows, and we can just return D at province/state. And now we can compare raw data.length, the length of the original data, to countries data.length. And we should get two different numbers here. 76. I don't think this is quite right because, okay, this is only including the ones that do have something for province/state. We want the ones that don't have anything. So if I just had an exclamation mark right there to invert that Boolean, now I should get the countries. 173 countries. And just to confirm, I'm going to console.log countries data at index 0, just to see the first one, to see what it is. And it happens to be Afghanistan. That's correct. And there's nothing for province/state. Great. So I'm just going to make a comment here. Filter out rows that represent provinces or states. And now, to do a line chart with multiple lines, we're going to have to come up with a data structure where we have, I think we need an array of arrays. The outer array is the different countries, and the inner array is the time points, the points in time. And exactly how we do this, I'm not sure. I'm just sort of going to go at it and see what it would look like to have multiple lines in our JSX here for line chart. So in the line chart, instead of having a single path, we're going to have many paths. And the way we would do this in JSX is to break out into a JavaScript statement, which, by the way, there's no control flow here, so you can't put if in here, and you can't put like const in here. It just has to be a single JavaScript expression that returns a value. So we can say countries.map. I'm just imagining we have a variable called countries, which is an array. And then we can take each country and map it to, and so I'm defining a function that will return whatever I put in parentheses here. And in these parentheses is where I'm going to put the path. And we have to, instead of passing data, we have to just pass the data for that particular country. And I don't know how we would get at that, but maybe country.data or country.values or something. We just need to map over the country's data. All right, sorry. Let's figure this out. Just to get a sense what we're dealing with, console.log countries data, it's an array where each of the objects represents a single country, but it contains the time series for that country. So we need to take the days like we did before. We isolated the days. This time, for each country, we need to return days.map day blah blah blah. And so what we have to do is say return countries data.map. I'll call the row D, and then I know for sure that we can access D at country/region. So I'll say const country name equals D at country/region. And let me just test that that is working correctly by saying console.log country name. Okay, that seems to have worked. That's great. So we've got all our country names. And what we want to do is return a time series for that country based on the days. And so we can say return days.map. So for each day we need the date, just like we had before. But here's where it's a different thing. The death total is, I'm just going to get rid of all that. All we need to do is extract the data value from the row. And so it's going to be d at day, I think. Yeah, that's what I did earlier with the summation. And so if I just use that same logic, and we needed to use unary plus to parse the strings into numbers, I think this should work. And so this is what's returned by transform. And I'm just going to add another comment here that says get time series data for each country. And now, if we say here, console.log data, the test here is didn't work. So we get an array where each entry is an array. That's exactly what we needed. Remember what I said in the beginning? We need an array of arrays. And now we've got it. So each of these arrays has a date and a death total. I'm seeing zeros for death total. Oh, there we go. 4. Okay, the date is good, it looks like. So now we can actually render the lines. And I'm noticing that we're not using country name, which feels kind of weird. Like, I feel like we should be using it, but I'll just comment that out for now and see if we need it later. But now we can render multiple lines. Let's try it. I'm going to uncomment what I've got earlier. And countries is actually going to be data. And country, I think, is accurate. Let me do one thing. I'm going to make sure data is in scope. Yeah, data is getting passed into the line chart. And remember, it was an array of arrays. So I'll call this country data and just pass that into our line generator. And we should have multiple lines. Let's see if it works. No, I'm not seeing anything. We're getting some not a number values. Oh, maybe I didn't initialize the scales correctly. Oh yeah, this is kind of a tricky thing, because now we're going to need to compute the extent over all the values in the nested arrays. Yeah, so instead of computing the extent over data, we want to compute the extent over all those arrays combined. And so let's just combine all those arrays by saying data.reduce. And so my idea here is, okay, data is an array of arrays. We need to get at all the inner arrays combined. So what can we do? We can just take all those inner arrays and combine them, literally concatenate them together. But that's the original data that we had. Trying to think the best approach here. I think the data is in the right shape, and we just need to modify our computation of the scale domains. And so I'm going to say we're going to take the extent of all data, which is something I'm going to define to have all the time series concatenated together. And we use that to compute the domain of the x scale and also the domain of the y scale. And so all data is going to be data.reduce. And I like to use this method of concatenating things or building up objects because it's a clean, functional way to do it. And let me just look up the documentation real quick for reduce on MDN. So array.reduce takes a reducer and an initial value for the accumulator, and then the reducer function takes as input the accumulator and the current value. And so that's what I needed to remember. The first argument is the accumulator, which I'm initializing to be this empty array. And then what gets returned, the second argument is the time series for one country. And I think I called that country data down here. Or I'll call it country time series, because I think I actually used the name country data in that other file. So let me just call it country time series. And so what we want to return from here is just the concatenation of these. I just want to concatenate all the time series data together. And so we can return accumulator.concat country time series. So I think that should work. Let's see what all data is. So all data is this array of 11,000 entries, which is sort of what I expected. And each of these entries has a date and death total. So I think we actually computed the right domain and range based on what's showing up here. Okay, so this is good. This is good. We're just not seeing the lines. I'll get rid of this debugging statement. And why are we seeing no lines? We're getting infinity, it looks like. Yeah, this is again a gotcha of the log scale. But we're starting at 1. Let me just see what the log scale domain is. Well, no, I know what it is because we see that the tick marks go up to like 2K. So we are debugging these paths. So let me add some debugging statements into here. I'm going to convert this from an ES6 function that returns something implicitly to explicit return, so I can put the console.log statement. So I'm going to change that ending paren to an ending curly brace, and then explicitly return that. And then we can console.log country time series here, just to make sure it's the right thing all the way inside of here. It looks correct. We got date and death total. What's the problem? It's going to be ultimately calling this line generator, which is going to evaluate x scale of x value of d for one of these. So let me just see if that works. So country time series, let's just look at the first one, because that would be the equivalent of d. Let's see, does this work? X scale of x value of this object here, we get 0. What about, yeah, that looks correct. What about y scale of y value of this? We get infinity. Okay, I've narrowed down the problem a little bit more. Why do we get infinity? I don't know. Well, do we get the right y value, which should be the death total? It's 0. 0. Yeah, so I think with log scales, you just can't pass 0 in. Let me research. Yeah, this is like a weird thing about log scales that I just don't really know how to get around. So I think we can just add some epsilon. Like, let's just add 0.1. It seems silly, but might be the ticket to getting it to work. Oh no, that has to be inside the invocation of y scale. Okay. So now we get these lines to show up. Or you know what? We should just return 1, because that's where the axis starts. I don't know. This log scale thing is a bit tricky. What if we started at epsilon? Okay, so I'm noticing this one starts at 1. What if I started at 0.1? Just to get the log scale to comply. I don't know. I'll call this epsilon. And then I'll add it here. And we can define epsilon to be, let's try 1. What's wrong? Oh, it's typo. So if I spell this correctly. Okay, this is pretty much working. Yeah, this is great. This is great. We have a lot more work to do, but at least we got all the countries on here. And, you know, we could make the lines different colors. I kind of want to see different colors on here, but we're not going to have enough colors to use. I don't know, but this is kind of a good starting point, I think. Yeah. yeah, this is pretty cool. So what I want to know when I look at this is, what is this country out in front? Like, who is that? And what are these other lines? We need to add labels here, and or some way of interacting. One way of doing this that I can see is just adding labels over here. See, there's actually little gaps between these lines. And we could fill in labels, at least for the top ones. These ones would get too crowded, but you know, if we have enough space, we could add labels right along the right. And then maybe like hovering them could make them highlight or something like that. But
hey, Grant, here's you mentioned something about colors. How you think you'd run out of colors?
yeah.
What if something that for each line you would just use something to just randomly generate a hex value and use that as the color, and you would have that color correspond to a legend elsewhere on the page. Millions of combinations of that, you definitely not run out of colors.
Well, the thing about colors in visualization is, even though you might have two different hex values, you might not be able to tell them apart, because some of the colors are so close together. But just
two slightly different shades of pink.
Yeah, exactly. And I think a good rule of thumb is like the number of colors, the max number of colors that you can perceive is like around 12, I think. So, but let me just try something experimental. I'm just going to make all the lines random different colors as you suggest. So if I say the fill on this is a string that says RGB, let me just put in some values to get it started. Oh, it's not working because, oh, this needs to be stroke. That's how you set line color. Why is this not... why is this not working? It should at least be... If I say stroke is red, they should turn red. What? Oh, is it being overridden by my CSS? I think it is. Yeah, CSS takes precedence, oddly enough. So if I get rid of the stroke definition here, now it works. Okay. So what I was going to do is make these all random colors, which I think would be fun and cool. So I'm going to break into an ES6 string template literal, say RGB, and I want to make these random values for red, green, and blue. And the way we can do that is say math.random, which gives us a number between 0 and 1, so we can multiply that by 255, because the range of RGB goes from 0 to 255. And then I can just, copy this for red, green, and blue. Green and blue, and we have to put curly braces around this whole thing. And looks like there might be some problem, like a syntax error. What is it? I don't know. Let me do this more cleanly. Make a variable, make it RGB of, I'm going to say R, G, and B. And then R is going to be math.random times 255. Okay, now everything's correctly formatted, and we can say G and B like that. And then the stroke on here is stroke color. Okay, yeah, we get different colored lines. See that? So that's what happens when you use random hex values, random RGB combinations. Pretty cool.
Nice, but you're all right. It would be kind of difficult to distinguish.
There seems to be, for example, a lot of overlapping greens. Like If you had to distinguish
Yeah.
between this green here and this green over here, you'd be hard-pressed.
Mm-hmm.
But it's a cool idea, and yeah, definitely worth looking into. But just to recap where we're headed, this one by John Byrne Murdoch uses color, actually. Yeah, interestingly, he does use color here, but I think it sort of has a different meaning, because look at this. Japan and South Korea are the same color. Maybe it's grouped by region, see that? And France and Spain are both blue. That's a cool idea. It's a cool idea.
Yeah, it also might be similar rates.
Yeah. But one criticism I have for this visualization is that it should include a color legend. It's missing a color legend. Maybe somewhere in the article they say what color is. But if I search for color on the page, I don't see anything. John Byrne Murdoch, if you can hear me, put a color legend, man. Don't know what the color means. He's doing some amazing work on this. Amazing work. This is some cool idea, actually. Okay, everyone. I'll be back. So, we made it this far. We've got lines on this line chart for each country, but you can't really read it. I mean, the lines don't have any labels. So I think we're going to need to add some labels to these lines. Alright, so my goal here is to add labels. Let's get started adding the labels by forking this visualization. And I'm going to rename it to Coronavirus Deaths Over Time by Country with Labels. And you know, that color was cool and all, but I don't think it's actually really helping us here. So I'm just going to get rid of that color on our lines. Yeah, let's set the stroke color. Well, I'm just going to get rid of this stuff that sets the stroke color for now. Let's just keep it as a fixed, like black maybe. Okay, we've got all these lines, and at the end of them, at the right end, I'm thinking is where we can put these labels. And you know what? This reminds me of a really cool interactive thing that I saw on blocks.org. Let me see if I can pull that up. This one. Yeah, so now it's in observable. But this is the one I was thinking of, where there's a Voronoi overlay on top of it, which is super cool. I wonder if he's still got that turn on Voronoi. There used to be a checkbox where you could turn on the Voronoi. See, in the original on blocks.org, there was this checkbox, which I think is super cool, and it's missing in the observable version. So, anyway, if you hover over here, the Voronoi polygon that you hover over determines which line it matches up to. So I think this interaction would be tremendously useful for the situation we've got right now, because it's quite similar to this. You've got a bunch of lines that are all sort of on top of each other, and what you want to do intuitively is hover to see which is which. So maybe this is the better road to go down instead of trying to add labels. Although labels are great, you know, you could print it out. So we're facing a fork in the road. What do we do? Should we try to add labels, as in the John Byrne Murdoch example, or should we try to add interaction so you could hover? I've never done a video on Voronoi, and I've always sort of wanted to, so I'm leaning toward doing this. Putting the Voronoi overlay. That would be fun, wouldn't it?
Leaning toward the Voronoi, it looks a bit more interesting on labels.
Right? I agree. Yeah, it's a little more interesting. Yeah.
Yeah, like I have no idea how that thing works, and labels I've definitely done before.
Awesome. So Voronoi it is. So let's try to add this interactive Voronoi hovering technique with the tooltips and the highlighting, like this, to our lines here. So I think I just forked this. Yeah, so instead of labels with Voronoi overlay. Because this is a technically cool thing to get working, and it's just sweet. What can I say? And so let me update the styles of the line to be the background data. Meaning I'm just going to change the stroke color to, let's say, gray. And that works. Yeah, because gray is a named CSS color. There's all these named CSS colors that we can draw from, and this is one of them. And they look a little thick to me. I think I'll just make it a little less thick. I think that's in our CSS. Actually, we defined stroke and stroke width for our marker line in CSS, and then I changed the JavaScript to override it. So let me just change this JavaScript back so that CSS is in control of this. Yeah, so we're going to lose our stroke color, and that's just fine. And then back in our CSS, when we style this marker line, it says stroke is black, but wait a minute. So marker line should be a class of these paths. Did I accidentally remove the class? Yeah, so let's put class name equals marker dash line. I guess I accidentally deleted it at some point. Okay, there we go. See that? So now we're back to this happy place of editing the styles with CSS. Here is where I'm going to make the stroke gray. Or better yet, let me use some transparency and say, sure, stroke is gray. Let's make stroke black and then set opacity to 0.5. Let's see if that works. Yeah, so I like this approach better because you can bring down the opacity. You can see where there's a lot of overlapping things. But since we're eventually going to have a selected line, like a hovered one, I think I'll keep this gray. Yeah, so those are sufficiently in the background, but now the visual layering doesn't really work well with the tick marks. So I'm going to go and update the color on these tick lines. Yeah, so I'm going after the tick line. Yeah, this is the tick line. One of them. Ah, there it is. Ah, yes. There we go. So, yeah, if you dig hard enough in the DevTools, you can make this dynamic CSS color picker happen. And so that way I can pick a sufficiently light gray. See here it's white. There's no grid lines. And you can see these sort of faded out lines. I'm going to bring the grid lines back just a little bit. Just enough so you can sort of see them. And then I'll copy that hex code out of here and back into our code for tick line. There we go. I think I might want to do the same for the marker lines. So if I inspect these marker lines, here it is. This is how we can change the color of the lines. Pretty sweet. So that's black. I could give it a little hue, a little red. Or not. Let's just get it right in black and white. I like that phrase. Yeah, and the opacity, see, it might not be actually the best idea to use opacity because I just sort of want these all to blend together as background lines. And then there's going to be like one foreground line which we can make like red or thicker. But for the background lines, I think they should look kind of like this. Yeah, you have to copy it out of here. So that's the color for our marker line. And we want to turn the opacity off. Yeah, that looks decent. Okay, so the next thing up is to add this Voronoi overlay. Voronoi overlays are the craziest things. And essentially what we're going to be doing is adding more stuff to our line chart component such that the thing that it returns on the top, see, all these DOM elements are being returned, the path for each of these country lines, the text labels, all that. There's going to be a new sort of layer on top, which will be the Voronoi overlay. So I'm sort of writing what I would think of as the ideal code for this from the high level. The Voronoi overlay is going to be responsible for, partitioning the screen into these Voronoi polygons and then giving you this on hover event. And this is how I think I'm going to do it. On hover of these Voronoi segments will change some state, which we're going to manage in React. And that will in turn cause this highlighted line to render. And that's when we can display the label, just like in this example. See, I want to sort of make it almost the same as this example here. And our first step is to get here, to show these Voronoi polygons. So, from this perspective of our linechart.js component, I just want to say put a Voronoi overlay there. And it's going to have something like on hover, and this is where I'm going to pass in a callback. I'll call it handle hover. Or to be more specific, I'm going to call it handle Voronoi hover. Yeah, so I'm just going to define that as just a placeholder for now. Const handle Voronoi hover equals, and when we use callbacks in React, it's really best to just always use the use callback hook, because if you don't, every time this component renders, it's going to redefine that as a new function. It's not going to be cached from last time, which it is if you do use callback, and that would cause some inefficient rendering downstream. So this is just my habit now. I just say, okay, use callback. Second argument is the dependencies array, which is empty, so it's just going to define it once for now. And it's going to define it as console.log. I'm just going to say hovered. So this is like a test of, whether this is working. We should have the Voronois on the screen, and then when we hover over them, the console should say hovered, hovered, hovered. And then eventually we're going to know, what you hovered on, but I don't know what that is going to look like, but it's definitely going to come into this callback. So let's call it hovered ID or hovered, I don't know. Let's cross that bridge when we get there. The first step here is to define the Voronoi overlay component. And so let's do that. I'm going to make a new file called Voronoi overlay.js. So let's define this Voronoi overlay.js. What should this be even? I'm going to start by saying export const Voronoi overlay equals a function that ultimately is going to return some JSX of some sort. And I'm thinking, do we want to let D3 do the DOM manipulation, or do we want to let React do the DOM manipulation? So probably it's going to be a group element that has a path for every Voronoi segment. I think this might be a good time to look through some of those old Voronoi examples. Here's what it looks like in this example, which is using D3 version 3.5. That might be too old. The API may well have changed. So let me look at the version in observable. All right, let's study this multi-line chart in observable and see how it works. So the chart calls hover. We can use this thing to navigate to hover. And I don't know, this is sort of confusing code to me. Like, where is the Voronoi, man? Where is the Voronoi overlay defined? Is that called hover? I don't know. Where is the Voronoi? I don't know. Well, let me just look at the D3 Voronoi documentation. That seems like a dead end. I don't know. Ooh. Deprecation notice. Consider using D3 Delaunay. Okay. This is what we need. Compute the Voronoi diagram of a set of two-dimensional points. Ha! That's nice. Georgy the Voronator Voronoi. So he was this guy that came up with these crazy algorithms. So I think we need some examples of this. Let's see if we can find some here. Yeah, here's some simpler examples. This is perfect. Hover Voronoi. Yeah, demonstration of D3 Delaunay. Great. So it's an implementation using Canvas, but the Voronoi stuff should be just the same. I think this code here is what we need. And also this definition of particles, which appears to return arrays that have XY coordinates, which I guess is the default way of accessing with D3 Delaunay. But anyway, let's try this. I'm going to paste this code from the example, but I'm just going to comment it out for now because we don't have D3.Delaunay available. And to do that, we need to pull it in with a script tag in index.html. So let me go to unpackage.com/D3-Delaunay to bring this in. And then in index.html, I'll make a new script tag and paste that URL. And now, if we go over to Voronoi overlay, we should be able to say console.log d3.Delaunay like that, and it should be defined. Oh, I have another unrelated error. Use callback is not defined. So let me just go back to line chart, and yeah, this is where I used it. So we need to import that from React. Import React, comma, use callback from React. Okay, another reference error. Voronoi overlay is not defined. Yeah, so we need to import Voronoi overlay from Voronoi overlay. And now what do we see? We have something printed out that looks like a definition from D3 Delaunay. Great. And I've got some unwanted noise in the console from useData. So just let me get rid of that console.log. There it is. Okay, great. So now we've got D3.Delaunay defined. So we can go ahead and uncomment this. Const Delaunay equals Delaunay.from particles. And particles really needs to be points. I'm gonna just call it points. And I think this needs to be an array of arrays, each of which has two elements, an x and a y. But I'm not 100% sure. So let's check the documentation. Yeah, so I guess this is just how it works. Like you have to say Delaunay.from points. See, that's the name they use too. And points is an array of arrays, each of which has an x and y. And for us, the x and y are going to be the pixel coordinates for the lines of our line chart. So we should be able to compute a Voronoi from the Delaunay if we pass in the dimensions of our program. And that's easy enough. We just use the sample code and we pass in the width and height. So 0, 0, width and height. This is going to be inside of our inner rectangle. And so actually the dimensions are going to be inner width and inner height, which we need to pass in as props from wherever this is being invoked, which I believe is line chart. Yeah, and we definitely have these in scope here, so we could just say inner height equals inner height, inner width equals inner width. Uh-oh, we have a syntax error. Red alert! It's in Voronoi overlay. Oh, points equals. Yeah. Right. Let's just for now put some dummy points in there before we can get the data working. And so I'll put one at 0, 0. I'll put another one in the middle. Let's say 200, 200. And I'll put another one at 150 and 400. So this should work. Oh, it's a syntax error for this array. Gotta close out that array. There we go. All right, so now we should have console.log Voronoi, and that should get us the polygons that we need. Yeah, look at that. Would you look at that? That is pretty cool. Pretty cool. So I think triangles is what it needs, what we need to render. But you know, it looks like D3 Delaunay or Voronoi has a built-in render method. Maybe this one has the answer. How do we render these polygons? Like, what do they do with Voronoi once it's defined? Oh, look, Voronoi.render. What? Okay, so this is rendering it using Canvas, but how do I render it with SVG? Okay, so look at that. If a context is not specified, an SVG path string is returned instead. Okay, good to know. Good to know. So let's try that. Let's just try making a path where D equals Voronoi.render. And then we can make that a self-closing thing. It might be working. I think we just need to style this path. If we make the fill red, stroke red. Ooh, look at that. We are doing it. It is rendering it. This is kind of weird. Oh, I think the CSS might be overriding. Yeah, see, path? Path is getting set to fill of none, but I think that I wanted it to be the domain path. I don't even know what that was. Oh, it was for the marker line. Okay, so I think those paths should be getting filled in. I don't know why they're not. But, you know, I don't want just one path. I want to have multiple paths, you know, one for each of these Voronoi polygons, and I'm not sure how to do that. Yeah, so the question is, how do we get the list of polygons from Voronoi? Ooh, render cell. Render cell. This is what we need. Voronoi.render cell. So we give it I, looks like. So what we have to do is, for each point, I'm going to say return points.map. So for each one of these points, we're going to render a path. So I'll set it up so that for each point, it returns a path. And we can say Voronoi.render cell and pass the index I into here. And the callback takes as input the point, but also the index I, which we can use. So let's see if that works. Okay, well, it may have worked. Let's see what we've got in terms of DOM elements. I would expect multiple paths. There it is. I just see one path, though. Wait a minute, I'm just a little confused about this. Because this should be returning multiple paths. Just to make it really explicit, let's return a group element with a class name of Voronoi. And then within here, we're going to return many paths and then close out that group element. Looks like I got a syntax error. Oh, is it that semicolon? You gotta be kidding me. Is that it? Oh man. Okay, there it is. There's our Voronoi overlay. Finally. But let's just really see it. Let's set the stroke to be something else like black. Okay, cool. I'm gonna set the fill to be a semi-transparent black. Or, you know, I'll just get rid of the fill. Actually, fill should be none. Alright, so we've got some Voronoi overlay polygons there. We figured out all the plumbing needed to get from an array of points into rendering these Voronoi overlays. Now, let's derive this array of points from our data, from our lines. And remember, in linechart.js, we computed all data, which is all of the time series sort of combined together. So this is actually what is needed to feed into the Voronoi overlay points. So we can pass in all data into our Voronoi overlay, like this. All data equals all data. And then over in Voronoi overlay.js, we can take as input all data And then we can define points to be, and I'll just comment out that old definition. Points can be all data.map, a function that takes as input d, one row, and returns an array that's going to have x and y. And so this is going to be x scale of x value of d, that's x, and then y is going to be y scale of y value of d. And then we just need to pass in x scale, x value, y scale, y value. Oh, do I have a syntax error? Oh, I need another ending paren. Okay, there we go. But I think something is wrong. What is it? Oh yeah, x value is not a function, right. So we need to actually pass these in from the outside. So let's go back to linechart.js and make sure we give the Voronoi overlay access to all that stuff. So x scale is x scale, y value, y scale, and y value. Okay, the program ran, but I'm not seeing the Voronoi overlay, and I'm not seeing any errors either. So I'm not really sure what's going on here. So points might be incorrect. Let me see what the value of points is, just as a first step to debugging this. Okay, the y value is infinity. That would be the problem. Yep, that's the problem. So it's y scale of y value of d, and this is where we added epsilon, I believe, last time to account for those zeros. And epsilon was 1, so let's just try 1 plus y value of d. Okay, there we go. Now it works. Whew, yeah, there it is. There's our Voronoi overlay that we can use to do sweet hovering interactions. Got it to show up. That's a pretty good milestone. Okay, we got it this far. But one thing I don't like is that this logic is defined in a couple places. I wonder if we could unify it, or at least say, like, I don't know, epsilon. At least epsilon should be centrally defined. I mean, I don't want to spend too much time on this, but let me just pass in epsilon from line chart. Yeah, it's defined right there. Or you know what? It's defined here, actually, in the line generator. So let me try that approach, actually, because I just don't like to define things multiple times. You know, this particular here, a y scale of epsilon plus y value of d. I believe we can get at that through the line generator. And in a way, that makes sense to pass into the Voronoi overlay. So if we just pass in line generator equals line generator, I don't think we need to pass in all that stuff. So it's a good simplification to do. And let's try that. In Voronoi overlay, instead of all that stuff, we have access now to line generator. And I believe we can say line generator dot x, and it should return a function. Yeah, but the idea is that we can say all data dot map, and then return line generator dot x passing in d, like that. And I think this should work, and we have to do the same thing for y, but that way it'll be centrally defined in just one place, but then used to multiple places. And this has to be line generator.y. And prettier is not putting that into multiple lines. Funny. Oh, syntax error. There we go. All right, it works. Sweet, it works. Okay, so that's a good simplification to do. Now our API is a little cleaner, and we've got these Voronoi polygons on here. Now, I think would be a good time to add the hover interaction. And so we can do that by adding listeners to these path elements, as a matter of fact. So let's do that. On this path, I can say on mouse enter equals, I think we had something called handle hover, or on hover. In linechart.js, we had something called handle Voronoi hover, and we passed that in to our Voronoi overlay component as on hover. On hover. And we don't need that epsilon anymore. I'm not using it. And then we can just pass in on hover to on mouse enter, and we should actually see it work. If I hover, see that? It works. Whenever I hover over something, it says hover to on ... So we're one step closer here. It's pretty good. The question now is, how do we know what we're hovering on? I mean, we didn't even pass any metadata into, you know, the Voronoi. We just passed in these XY pairs. So I don't know like what the best practice is. Maybe we could just use the index to go back to our original data points. Yeah, maybe in this on hover we could embed a new callback, but I don't want to create so many functions because there's so many points. I don't know. I feel like with D3 there's a cleaner way to do it, but with React, see, I really want to just define this once. So let me define it here. Let's try handle mouse enter equals a function, and then here I'll say handle mouse enter, and I believe we get an event to our callback. So what if I say console.log event and I hover? What do we see? We see these events that have... See, what I'm thinking is, can we use this event to get back at the original index of the array? I believe we need event.target. So event.target is actually the DOM element. Yeah. But the question is, for a given DOM element, can we get its index in its parent? I'm going to research a little bit about that. It's really going to be part of the DOM API node index in its parent. Yeah, here it is. Get child node index. Huh. Well, I don't want to be calling index of to figure this out. Yeah, that could work, but index of it's an expensive computation. All right, what is our main problem here? Our main problem is when we hover over one of these, we need to get back to the original data element. And how do we do that? Well, if we knew the index that this was at, then we could just say all data at index I to get back to it. But we don't have that index. So what if we just exposed the index as another like property on this path and then extracted it out in the handler? That way we would only have to define this handler once and not have to define a new function for each and every path element, which would work, but it's kind of an expensive proposition. But I don't know if it's cached, if we use Memo with that. You know, maybe that would be fine, because now I'm thinking we could Memoize it. So let's try that approach. What if on mouse enter we define a new function that will call on click, or sorry, not on click, on hover, and we just pass the index I. Or, you know, let's just pass all data at index I. Yeah, this should work. So now if I hover, it says hovered on, because we haven't exposed it. But the idea is on hover, we'll take as input the data element, I'll call it D, the row, and then we can just say console.log D to see the one that we hovered on. Let's see if it works. Hey, it seems to work. Look at that. But the problem here is it only has death, total, and date. It does not have the country, which is important to us. But that's not a problem because we can easily add the country information back in, because here's where we did our data transformation. And I remember it was weird to me that we were not using country name, which I had computed and then never used. So if we just put country name attached like this to these data elements, now this is going to come through in our hovering. So now if I hover, it gives me these objects that have country name, date, and death total, which are all things that we could expose in a little tooltip label that pops up. But I'm thinking what I'd like to do first is get the notion of an active line working, like an active country line, as in this other example. See, with this other example, there's a line that's active, and I really like that feature because it lets you really navigate pretty clearly through these lines. So let's work on that. Now that we have this hovering interaction working, let's work on making a highlighted line for the currently hovered country. So how would we do that? I'm thinking we introduce a piece of local state inside of our line chart to deal with the currently active country line. And the question is, what should we call it? Let's call it active country name. So I'm going to use React's useState hook. And to do that, we have to declare this destructured array like this, where the first one is active country name, and the second one is set active country name. Equals useState, and we need to import useState from React. And now, when we define this handle Voronoi hover, we can actually set the active country name. And we can do that by invoking set active country name, passing in d dot, I believe it was country name. Now, if in our rendering function, we just log out the current value of active country name, this should tell us if it worked or not. So as I hover, it works. See that? It's changing. Sweet! So that's how you can extract the country names from the Voronoi overlays that you are hovering over. Now, let's render an active line based on this value. So how would we do that? I mean, intuitively, it would be another line. So here's the logic that renders all the lines for this line chart. These are sort of more the background marker lines. And what we need to do is add another one of these marker lines, but it's going to be the foreground marker line. So I'm going to give it a class name of marker line, and actually, what are we calling the active country? I'll give it a class of active. And for this, the D, the SVG path string, is going to be line generator of country time series, but for the active country. So I'll just call it active country time series. Oh, I'm just realizing I destroyed our old code. Hold on. I'm going to bring that back. Yeah, we just want to make a new path on top of everything else, like this. So, but this is only going to show up if we have active country name defined as anything. And so to guard against that, I'm going to say active country name using this ternary operator. If so, renders that path, otherwise render null. And so this will guard against the case where we haven't yet hovered over anything. Now we're left with the problem of deriving active country time series. But I feel like this is also something that's sort of already defined. Let me just look back here. All data. Yeah, so I think the approach we're going to have to take here is to filter the data to just isolate that one country's time series. And you know, we can do that right in here, because if we know that there is an active country name, instead of having a separate variable, we can just say this is going to be a function of active country name. And so we're going to have to filter the data. Because remember, each element here is a time series that corresponds to one country. And so we can say data.filter. And data.filter takes, it's a native array method for filtering. And it takes as input one of those entries, which is going to be country time series. And so we want this to return true because we want to just isolate one country. Now that I think of it, we don't want filter because filter returns an array. We want find, which returns just one thing that it finds. So whenever this function returns true, it's going to return the corresponding element in the array. And so we want to check, is country times series dot country name equal to the active country name. And you know, I don't believe we ever defined country name on the country time series. So let's do that. Over in useData.js, when we transformed the data, we returned this, which is really country time series. So I'm going to make that into a variable called country time series, and that's what we're going to return. But we want to assign country name to be a property of this. So after we define it and before we return it, we can say, and keep in mind, country time series is an array. In the JavaScript language, arrays can have additional properties, which are sometimes useful. And in this case, it would be super useful to know what country this is just by looking at the array. So we can say country time series dot country name equals country name. Now it might work. See, as I hover, I think something's happening, but we didn't style the line any differently. So we're not going to see anything. So let's work on the styling. I gave the active marker line a class of active. So in the CSS, let's style it. Yeah, here we can say marker lane, comma, active. I believe comma is the delimiter for selectors, for selecting like things that have multiple classes. But here, let's make the stroke black. Ooh, no, that affected all marker lines. Oh, it's a dot. Yeah, if it has two classes, yeah. So if it has the class of marker line and the class of active, you can select it with dot marker line dot active. So now, if I hover, oh, see that? Something happened, but it's extremely slow. Extremely slow, and I think I know why. So let's solve this performance problem. And this is the performance problem that I had thought about earlier, and I think it has to do with re-rendering all the Voronoi points all the time. So the thing to realize here is that we only really need to render this Voronoi overlay one time. And as the active line changes, we don't need to re-render the Voronoi. We can just leave it as it is. And so to do that with React, this is a performance optimization. We can use useMemo. It's a React hook. So let me try that and see if it improves our performance. Import useMemo from React. useMemo implements this concept of memoization, which means a function depends purely on its inputs. It's not going to return something different each time. That's called idempotency. So memoization really only makes sense for idempotent functions, which ours happens to be. And ours happens to depend on, all the variables that get referenced here. And so we're going to have to say useMemo, pass in a function that returns this, and then specify the array of dependencies, where if any of these dependencies change, we do need to re-render it. But if we just change the active country name, none of these inputs are going to change, and so it's going to use its cached or already rendered version. And so that's why useMemo improves performance. In other words, when this gets rendered, all these DOM elements that correspond to these little polygons are not going to be touched. They're just going to be left in place. So there's going to be zero interaction with the DOM for those. So hopefully it should speed things up quite a bit. Let's see. The way we can do this, I'm just going to memoize this whole thing. So I'm going to say useMemo. The first argument is a function that returns this JSX here. And then the second argument is the dependencies array. And so anything that gets referenced in here needs to be in the dependencies array. For example, points, onHover, all data, and Voronoi. And with Voronoi is where things get a little tricky, because right now the code is not memoizing the Voronoi, and this expensive computation of the Delaunay triangulation, that's something that we really should be memoizing. So let's define it this way. Const Voronoi is useMemo. First argument is a function. Second argument is the array of dependencies. And in the body of this function is where we're going to define points, Delaunay, and Voronoi. But instead of defining this, we can return it from the function. So it gets assigned to this variable out here. Okay, now Prettier splits this up into 2 lines, which is a lot more readable. So we need to fill in the dependencies array for this. And so what does it depend on? It depends on all data, line generator, inner width, and inner height. And we're running into some problems because points is defined in here and not out here. But really what we want to memoize over is... Actually, we want to memoize the whole darn thing. So I just realized we can actually just have one useMemo statement with all these dependencies, and it can return this group element. Yeah, so instead of returning the Voronoi, so Voronoi is there, and then this function returns the JSX, which should be returned from our React component. So here's where we can say return useMemo and all this stuff. So let me just make sure there's no syntax errors or anything. So these are the dependencies that we had before, but the thing is, these are defined internally. We still need onHover. All data is already there. Voronoi is inside of there, so we can just add onHover to our dependencies array, and that should be that. And then if I close this, yeah, the corresponding closing tag is useMemo up there, and I think we're in good shape. So now the moment of truth, is it going to work? Yeah, it works. But let me just make sure that the memoization is working. And the way that we can do that is to put a console.log statement right in here. Ideally, it should just output once. And if it's outputting multiple times, we know we have an issue. Console.log memoizing. So we should just see it once. Okay, we see it every time it changes, which means that something is wrong. Something is wrong. Probably some of our dependencies might be changing. So here's how we can sort of test and debug to see which things are changing, because one of these 5 things is changing, but shouldn't be. So here's what I can do. I say useMemo, just as a debugging thing. A function, and then the array of dependencies. And so I can move this console.log memoizing to inside here. And now I can incrementally add things to see which one is actually causing it to recompute. So let's check if all data is changing every time. I doubt it is, but let's just check. So memoizing once, and as I hover, oh, it says memoizing again and again and again. I think we found our culprit, all data. So if all data is changing each time, why would that be? Oh, it's because we didn't memoize it at this level. Yeah, so if we memoize it here as well, so we use memo and return that thing, and then the dependencies array contains just data. Yeah, so only if the data changes will this recompute. And then we have to import useMemo from React. Now let's see if it works. If I hover, oh, wait a minute. I didn't put any debugging statements. So now, if we go back to useMemo in our Voronoi overlay, and we bring back that console.log memoizing, let's see, is it still updating unnecessarily? Let's find out. It is, unfortunately. Okay, so let's bring back this debugging sort of framework. At least when I hover, it doesn't say memoizing based on all data. And so that's good. See, it's just giving us the country names. It's not saying memoizing. So that means all data is good to go. All data is not any longer the source of our problem. But what about line generator? Is that the one? If I hover, it says memoizing, memoizing, memoizing. Why would line generator get redefined every time? So over in line chart, line generator is another thing that we could memoize. Yeah, so I think it's a good idea to just do that because we don't need to recompute this every time the selected country changes. So let's try it. Use memo, and the second argument is the array of dependencies, which in this case includes x scale, x value, y scale, and y value, and epsilon. So now when I hover, ooh, it still is saying memoizing. That's because we didn't memoize anything else. You know, we can really memoize our scales as well. Probably should. But let's memoize this x scale, whose dependencies includes all data and x value. And let's do the same for our y scale. Use memo, function that returns the scale, and an array of dependencies, which includes epsilon, all data, and y value. Now, is it still updating too frequently? No, it's not. Hey, we solved it. Woohoo, yeah. And you know, it's feeling more snappy. It's feeling quite a bit snappier. Let me check. In our Voronoi overlay, if I comment out this little debugging trick and go back to the original rendering, the whole rendering, now if it only prints once, then we've solved the performance problem completely. So let's check. Memoizing, and if I hover, no more memoizing. See that? And it's much more performant. It's much faster. Yeah. Cool. Yeah, this is pretty cool, pretty good. So I think I'm going to take a break, and when we come back, we can add the little labels that say actually which country it is, the date, and the number of deaths. So you could hover over and see what exactly does each point represent. So stay tuned. So last time we got this Voronoi overlay working. Let's check it out. We can hover over these various places and the nearest line will highlight. That's pretty cool, but it only gets us part of the way there. Our goal is to reproduce this, where we actually draw a point and a label with the information that corresponds to that particular point. So in our case, with this coronavirus visualization, the label should say country, and it should also say the date of that point and the number of deaths. I think it's pretty doable. Let's start by rendering the point, meaning just that one little circle. I'll start by forking this one and renaming it to Voronoi overlay with labels. So I'm thinking in linechart.js, this is where we are currently rendering this Voronoi overlay. It's right here. And now's a good time to step back and think about the composition of all these things. See, rendering of the active line is not done by Voronoi overlay. It's done by this code over here that responds to the current state of active country name. I think we need something similar to that. And you know, we can put it right on top of this path. Let's put it right here. Let's make a circle. And now we get this error, one of my all-time favorites. Adjacent JSX elements must be wrapped in an enclosing tag. The problem here is that we've got a path and a circle right next to each other coming back from this JSX, but they need to be enclosed in something. I'm going to use a React fragment just to get around that error. And that circle should be at the point of, the center. Well, actually, what should it be? It should be the point that contributes to that point of the line. So it's going to be a vertex of the line. That means that we're going to have to get access to that whole selected data element. Because, when we hover on these Voronoi overlay polygons, we're actually selecting a data point. And then we're using the country name of that point as the active country name. But really, maybe having an active country name is not the right thing to be having active. I mean, maybe we should have active a point. You mean a data point, a row from the data table. And then from that, we derive active country name. The next step here is to figure out where we're invoking set active country name so that we can change it to invoke, set active row. Yeah, set active row. Down in handle Voronoi hover, we actually have access to that column. So instead of saying set active country name, we could say set active row. And we just pass in D. And in this simple case, we can actually simplify this because it's just a function that takes as input D and then passes that into another function. So we can just pass in set active row to use callback. Yeah, I think that should work. And then we need to change country name to row. So now we've got active row and set active row. And then we console.log active row. And if there is an active row, then we use it here to test which line we should be highlighting. And so instead of comparing it to active country name, we compare it to active row dot country name. Yeah, and I think this should work still. Yeah. Okay, so now we have active row, which gives us the information we need to get the exact x and y coordinates for the circle of our label that we're going to place. So we've got this block of code here that only renders something if there is currently an active row. And in here is where we've got this circle, and we need to figure out cx and cy of this circle, which are the pixel coordinates. And our approach with the Voronoi was to extract these accessors from the line generator. We can say line generator.x of what would be D, but it's going to be called active row. Yeah, see, because when we created the line generator, we set the x accessor function to be this. It just takes the row and passes it through y value and y scale, and the same for y, but y has that epsilon to deal with the log scales. So we've got our cx. Let's make our cy. It's going to be line generator.y of active row. And in order to see the circle, we have to specify r, the radius, and I'll just say the radius will be 10. And let's try it. Okay, we get a circle that is not at the right spot. Oh, I think it's because, yes. We need to invoke x and y as functions, because when you invoke lineGenerator.x as a function, it returns the function that you passed into it earlier. And so, this statement here returns a function, and then that function gets called, passing in the active row. So now it should work. All right, look at that. It works. Pretty sweet. That is awesome. The hovering doesn't seem to be, I don't know. It doesn't seem to be right, because see, look, I started moving over here, but it's not moving to where I'm hovering. I think there might be something wrong with which events are being caught by these polygons. So it looks like it only moves when I hover over the lines. See, if I jump to the internal part of something, it doesn't catch it. But if I hover over the line, then it catches it. It might have to do with fill being none on the... You know, let me migrate to CSS for determining the fill and the stroke and stuff like that. I'm going to give this a class name. Oh, wait a minute. The parent already has a class name of Voronoi. So now we can style these paths in our CSS. Over here, we can say .Voronoi space path to select all the paths that fall within that Voronoi group element. And here we can say fill is none. And now, does the interaction still work? No, it doesn't. It does not. See that? And I think it has to do with this other property that we can set, namely pointer events. All. I think that should do the trick. Yeah, there we go. There we go. Yeah, so that's a little trick that you need to get this thing to work. Because if you don't have pointer events all, it doesn't get the events, because by default, if the fill is set to none, well, if you can't see it, you shouldn't be able to click on it, right? So it doesn't get the mouse events. But we want a specific scenario where it gets all the mouse events, even though it's invisible, because it's our trigger for interactions. And now, you know, now that fill is none, this is a lot more smooth. And stroke is none, this is a lot more smooth, because the SVG rendering engine has less to do every time this changes. Yeah, so, okay, great. We're well on our way. Now we just need to add that label on this circle, or next to this circle, or above it, or below it. Let's see, what did they do in that other example? Yeah, this is from Mike Bostock's original, quite old multi-line Voronoi example. When you click on those links, it takes you here. What he did here was put the label on top. And that's a pretty elegant solution. When you go over here, it gets cut off a little. But, you know, it's not the end of the world. And, you know, we're really quite close to doing this. We just need to make a few changes. So over in linechart.js, here again is our friend, that bunch of code that only runs if there's an active row. Let's add into this a text element. And inside this text element, we can put some text. I'll just put foo for now. And then as we hover, oh, I don't see it. Oh, that's because it doesn't have X and Y properly defined. And now that I think of it, the circle and the text, it might make sense to put those inside of a group element so that we can just translate the group element. I think I'll do that. I'll make a group element, set the transform to be, I'll close out the group element, put the circle and text inside, and the transform is going to be translate by something for X and something for Y. And that something for X is going to be lineGenerator.x of active row. And that something for Y is going to be lineGenerator.y of active row. And now we can get rid of the CX and CY definitions for our circle. And now let's see if this works. Okay, look at that. We get some text labels. Woohoo! Love the text labels. Now what? We need to clean this up a little bit. See, it doesn't really look that good. And it just says foo. It needs to say a bunch of other stuff. And that other stuff needs to come out of active row. So just to jog my memory, I'm going to say console.log active row. And as I hover, we get objects with country name, date, and death total. So we can access any of this inside of this text label that we're putting here. So we can say active row dot country name to put the label for the country. And now we can actually read this visualization a lot better than we ever could before. See that top line? That's Italy. Italy has had the highest number of deaths so far, cumulatively speaking. Next is, looks like Spain. Well, I gotta improve these labels. But you get the idea. Let's read it in more detail once we improve the labels. One thing I notice about this text is that the alignment is not really what I would like. I'd like it to be centered. Or maybe, you know what, with this particular visualization, we can make a choice to make the labels extend to the left. That way, even if you hover over the very edge of it, you would get a readable label that's all on the screen for you. So for that, we can say SVG text align, text anchor. We can say text dash anchor is end. Let's try that. Yeah, it looks like that works. That is good. That looks good. Now I'd like to move it a little bit farther away from that point because it's sort of intersecting with it. For that, we can just set the X of the text to be, I don't know, -4. I think it moved it, but just to make sure, let's say like, I don't know, -40. Yeah, now it's a little too far away. So let's say X is -10, and let's say Y is also -10 to give it a little more breathing room. Okay, now we can read it and interact quite smoothly and see that Italy is the top. Spain just overtook Iran for the highest number of deaths, and Spain's velocity or trajectory or the slope here, it looks vastly steeper than the one for Iran. There's France and the US neck and neck, and then the UK is getting slammed right now. The Netherlands, Germany, Belgium, Switzerland. South Korea is really slowing down from what you can see here. Yeah, wow, this is fascinating. Fascinating. I want to improve the labels just a little bit more. I think they can include more information. Because when you hover over, you actually get the country, the date, and the number for that particular date. And so you could even formulate it as a sentence, like Italy, 1,000 deaths as of, and then put the date. Maybe that should be our label. Let's give that a try. So we've got activeRow.countryName, and activeRow is an object with country name, date, and death total. So let's bring in deaths total to our label. We can say country name, space, death total from the active row, and now our labels contain more information. It says Italy, 21 deaths, but it needs to really say as of which date. So let's add as of active row dot date. And there's an error here because active row dot date is not a string. I can tell you right now that's what this is about. So the thing is, we need to format the date for human consumption. And for that, we can use D3 time format. Here's how you can use D3 time format generally. You can say time format and give it a specifier for how to represent the date, and then you can just say format time and pass in a date object. So I think I like this format, June 30th, and I guess we could add the year too. It would make our label longer but would be explicit, because I think it might go back into 2019. So let's try this. When we put our date here, I'm going to pass this through a formatting function, which I'm going to call format date. And this has not yet been defined, so at the top of the file, Wait a minute. It has been defined. That's weird. What did I use that for? It says February 28th. I think I used that for the labels earlier, but you know, I'm going to use a more explicit format because I think it demands this level of, I don't know, formality. But see, it makes the label quite long. See, March is coming from that uppercase B. And if we change that to a lowercase b, it shortens it to MAR. All right, I think this is pretty good. We can just style the labels a little bit differently. Like I think well, I don't know. The text feels a little too big for this. Maybe it could be more similar to the axis labels. To do that, we can add class name to our text here. I'll call it Tooltip, and then we can go over into our CSS and add some CSS for Tooltip. And you know, I kind of want them to look similar to the axis labels, so I think I'll just add that to here. .axis label, comma, .tooltip, to style the tooltips just like the axis labels. It's not quite right because I think it should be black though. So let me just override the fill of just the tooltips to be black. There we go. Unfortunately, you can't read some of these over here, but I think maybe that's acceptable. The main focus is what's happening over here. And I'm realizing as you get up here, it overlaps with the title. That's something we should fix. And also the number of deaths could be comma formatted. I see it's 2503 deaths. That should be 2503 with a comma. Yeah, so let me do that real quick. Yeah, in linechart.js, here's where we're putting the death total into the tooltip. So we can format comma active row.death total. And then we need to define format comma. I'll say format comma is not time format, but just format, and the format string specifier will be just a comma. And we need to import format from D3. Now when we hover over these, it says 2987 with a comma. Let's address this one last thing of these overlapping labels here. I think we'll just make this title smaller and perhaps left justified. So here's our text label. It's being transformed to be in the middle. I think I'll remove that. And I think I'll also remove this text anchor middle because the default text anchor I believe is start. Yeah, it looks pretty decent. And then I'll style this with CSS by giving it a class name of title. And then over in our CSS, we can make the title the same size as the axis label in the tooltip. Could add just .title there. But now it's a little too sedated. I think I'll make the tooltip and the title both black. Okay, this is working. I think this is fairly decent, although it still overlaps. I think we could even go smaller. 24 is actually pretty big. Let's try like 18. This is more like if you were to do it on print, this would look decent. But now we don't get that overlap anymore, so that problem is solved. That's good. That's good. One last thing I want to add here is that I want to add a little stroke around the text to make it pop in a situation like this, where it's black text on sort of a busy gray background. We can do that in the CSS of the tooltip by saying stroke is white. Let's see if it worked. Oh no, it's not as simple as I thought. I remember, this is a kind of a tricky situation where, yeah, to solve this, you need to actually have two text elements, one behind and one in front, the one in front is the one that we have now, and the one behind is the one that should be stroked, so that the stroke only goes outside the text and doesn't go inside it, which is what we're seeing now. So let's strategize a little. We can say there's going to be a new type of element that has a class of title-stroke. And that comes, conceptually behind the title. And that's the one where the stroke will be white. And we don't want to set the tooltip stroke to be white, just the title stroke. And it's not doing it yet because we haven't introduced the title stroke element. Yeah, so what we want to do is have another instance of the tooltip, but have it be behind, and give it a class name of tooltip-stroke. And this is bad practice with this copy-paste, but we can refactor that to make it all defined in one place, but just have two instances that vary in their class name. Okay, so we're seeing two of these, but I think I got the class names wrong in the CSS. Yeah, it shouldn't be title stroke, it should be tool. Now let's try that. Well, the font size needs to be the same as well. Okay, now I think it's working. But it's hard to see because the stroke width is not that much. So let's set the stroke width to something like 6 pixels. Now you can see the effect. See that? It gives a nice popping effect to those text labels. But I think 6 might be a bit extreme. Maybe let's say 2. A little subtle readability improvement. Or maybe, I don't know, maybe 3 is okay. And you know what? This is suffering from one of my personal pet peeves, which is the plurality used with the number 1. See, it says there, Moldova, 1 deaths as of March 20th. But if it's 1, it should say 1 death, not 1 deaths. So how can you solve this problem? This is a classic problem that comes up all over the place with different applications. So now that we've got 2 of these, we're feeling the pain of copy-pasting. I think I need to do the refactoring right now. And I'll just give it a name of tooltip. And we're going to have 2 of these, and the second one is going to be, well, we can just pass in the class name like this. Class name is tooltip stroke, and the class name for this other one, for the one behind, is just tooltip, and these should actually be reversed. Yeah, the tooltip stroke comes behind, and then the tooltip without the stroke comes on top. And then let's define tooltip as this logic here. So I cut that logic. We can define tooltip to be a function that returns a text element. And this needs to know about active row. Yeah. So this is a candidate for extracting into a separate module, but it's so small, so I'm just going to leave it there for now. All right, we've got a tooltip. The thing is, we need to take in that class name that we specified. So the class name is not always tooltip, but it's going to be whatever class name you pass in. And now it should be in working order again, I think. Oh, looks like it's broken. Ah, yeah, we need to pass in the active row. Now it should work. All right, it works. Sweet. Now that we've done this refactoring, we can solve the problem of that one case in one place, not twice. So let's deal with that problem now. Philippines, 1 deaths as of. So the deaths should be just death, 1 death. Let's solve that problem. So here's deaths, and the S is something that we can handle separately. And what we want to say here is if the active row dot death total is greater than 1, then add S. Otherwise, don't add anything. So now it says 1 death. but 2 deaths. Oh, but there's a space. Let's get rid of that space. Why is there a space there? Yeah, this is where it's getting a little messy to do it all like in line like this. You know what we could do is, instead of putting death outside, we could put death inside. Yeah, so if the death total is larger than 1, we use deaths. Otherwise, we use death. Is that going to work? 1 death. Oh, but now there's no space before it. There's no space before it. I think we do need to include something like this, which is kind of weird. But that's JSX. Okay, that looks decent. Yep. And you know what I'm kind of missing is the ability to hover over the right margin area and get something accurate. That might be possible. It's because the Voronoi overlay only goes up to the edge of this inner rectangle. But I'm curious, if we just extend that Voronoi overlay past inner width, I mean, what if we use inner width plus 100? Like, I think it should still work just fine. Yeah, there we go. Yeah, it's working. And we get some interactive space over here. That's great. That is cool. I think I'll keep that. Yeah. And down here, I don't think it makes sense to have any interaction. But, yeah, because there's so many overlapping points. But over here, it's definitely a big win. But just to be technically consistent, that value, 100, should actually be margin.right. And I don't believe we have access to margin yet here, so let's add margin as a prop to Voronoi overlay, and then where we invoke Voronoi overlay, we can pass in margin as a prop. And that margin, I believe, is defined at the top of this file. Yeah, there's the margin. And that could easily be made a prop. Doesn't really matter. All right, cool. Now we've got that interactive space on the right. We've got our Voronoi working. We've got our labels working. We got our title working. We got no overlaps. I'd say we have a pretty solid product here. Yeah, this is pretty cool. Pretty cool. So I think that about wraps it up. I'm pretty satisfied with this result. And so I think I'll call it a day. I think maybe I'll just do a quick overview. So yeah, this is the end product. We've got this multi-line chart where it says global coronavirus deaths over time by country. Each of these lines is a country. And it's cumulative deaths with a log scale. And we've got this Voronoi overlay that helps us get these tooltips working. And here's how the code is structured. Just real quick, I'll do an overview. Index.js loads in the data and invokes this line chart component. And this line chart component takes as input the data. We did use React useMemo to optimize the performance. So that's why it's so fast. It was really slow at some point. So that's where we're memoizing everything that we can. Computing the X and Y scale, computing a line generator. Oh, I got some cruft. I'll get rid of that. And then this file produces an SVG and a group element to create the inner visualization rectangle, X-axis and Y-axis components. And then the new thing is we've got this notion of an active row. And so it renders this Voronoi overlay at the end, which puts these polygons on top. And actually, we can show that by with CSS. We've got this class of Voronoi. And in our CSS, we could just set fill to be, or let's set stroke to be black. Or how about green, just to see it. And so this is these are the polygons that have the event listeners that are setting the selected point. So yeah, that's what we built today. Cool. Yep, a lot of details. A lot of details. And I would encourage you, by the way, to fork some of this stuff and maybe try to modify it. One thing I wanted to do is to get this to work over the county data, which is newly released by Johns Hopkins. So if you have any free time and want to do a homework assignment, you know. Awesome. Yeah, they just released the county level data this past week, and it's growing and growing, and so there's going to be a really sweet time series that comes out of it, so we could visualize it and see which U.S. counties are hit hardest and have it updating every day. It'd be super cool. All right, signing off. Take care, everyone. Bye. Hello, Curran here. Let's dig into a fun project about graph drawing with nodes and edges and D3 Force. Someone came to me and said, I want something like this. And this is the data that it should show. This work is for a foundation, and their goal is to show their vast network. So the foundation is connected to the Arts Web, and within the Arts Web, we've got Community Vision, Silicon Valley Creates, and within each of these, they just want to have, 20 or so smaller unidentified nodes just to demonstrate the volume of unnamed arts entities associated with this node. So, for example, Arts Web maybe would end up as one of these big hubs, and then Community Vision would end up as one of these smaller nodes connected to the hub. And then their vision is that these smaller hubs would have a bunch of tiny, tiny nodes that don't even have names. So this is the task before us. I'm thinking, I'll do it in VizHub and just use probably D3. Oh, and by the way, the deliverable, what they're looking for, is an image at the end. So no need for advanced interaction or anything like that. So I'm going to go to VizHub, Data Visualization Platform, and then I'm going to sign in with GitHub. Entered my username and password, and I'm in. So I think what I'll do is go back to the home page and look at the most forked and start from this hello HTML example. I'll go in here, click fork this viz, and I'll start by opening the editor and setting the title to be Organization Network Graph. I know for sure we're going to need D3, so let me just pull in D3 from Unpackage, which is my go-to source. All right, we're at version 6.2. Nice. So I'll make a script tag and set the source equal to that URL that pulls in the D3 library from Unpackage. I notice the description is out of date, so I'll just clear out the README. Okay, I know it's going to be a D3 Force layout. So let's check out D3 Force, the package that provides this functionality. And let's see if we can get something like this up and running, maybe with like 2 nodes to start. This looks like the opening move right here. So I'll copy that, go back to the code, and then I'll start building our JavaScript. I'll create a file called index.js, and in this file I'll paste that, but in VizHub we can import force simulation from D3. So we don't need D3 dot, and let's say import force simulation, and by the way, control space will autocomplete from D3. And this is a variable. The documentation used var, but let's upgrade it to the more modern const. And we pass nodes into force simulation. So let's see, what should nodes be? The API reference says, all right, d3.forceSimulation creates a new simulation with the specified array of nodes. And so if I click nodes, okay, each node must be an object. What I'm really looking for is an example of the data structure. Here we go. Here's a good example. Nodes and links. Let me just copy this. So it creates 3 nodes, Alice, Bob, and Carol, and then the links have source and target. So this represents the connections between Alice and Bob. And the reason why 0 maps to Alice is because Alice is the first one in this array, and the index of this entry is 0. So 0 for Alice, 1 for Bob, 2 for Carol. All right, let's use this as our starting point. I'm just going to drop that in here and change var to const for just style. All right, so now we've got nodes defined, passing that into force simulation. But what about links? We're not even using links. How do we get the links in there? And keep in mind, our goal for right now is just to get something to show up with a force simulation. And then after that, we can add our particular data. But let's get links associated with this simulation. How do we do that? It looks like the constructor just takes nodes as input. But if I just search for links, look at this. Yes. What we need to do actually is add a force to the simulation like this. And you know what? All of these simulations look good. Okay, so I'm remembering now that force simulation it doesn't really have any forces in it. And you have to add these forces yourself. This was an API change sometime in D3. So we need to add the charge force, which I'm pretty sure spreads things out. It sort of repels things from each other. And then the link force pulls things together that have links between them. And then the center force just pulls things towards the center of the screen so it doesn't go, wandering off. So let's just grab this whole thing and drop it in here and remove this unnecessary line that we already have. At this point, I'll run prettier just to get nice indentation and formatting. Okay, so instead of D3 dot, we can import force many body from D3 and also force link like this and also force center. I'll run prettier again. And we got to remove this D3 dot. Okay, now this should conceivably work, but we need to somehow display the result of this, and we can do that with D3 too. It says here the simulator starts automatically. Use simulation.on to listen for tick events as the simulation runs. So a tick event is when all the positions change a little bit. And this corresponds to animation frames, where we can re-render the graph and get that cool, bouncy kind of animation. So let's try simulation.on. I think we can just say simulation.on and pass in tick as the type, and then pass a callback function that gets invoked on each tick. So let's try that here. Simulation.on tick, and then pass in a function, and then I'll just say console.log tick. Okay, now we've got something that should actually run, but I don't think we've actually wired up this stuff yet. So in VizHub, it uses rollup to take index.js and parse this import syntax and then generate bundle.js, which is vanilla JavaScript that we need to ultimately include in our index.html. So here's what I'll do. Instead of this script right here, I'll say this script, that should be inside the body. This script has a source equal bundle.js. And we can get rid of this hello HTML. We can also get rid of the style on the body for the text, which we don't need. And let's see what happens. Does this run? If I open up the dev tools, check that out. We got 300 ticks. Okay, our goal is to render this somehow. And I think the go-to tool of choice is SVG. And we could create the SVG programmatically, or we could just drop it here in HTML and give it an ID so that we can query for it. I'll just call it container. And here we can set the width to be 960, which is the default width in VizHub, and the height to be 500, which is the default height in VizHub, inherited from blocks.org. Run prettier. Okay, so to get something, oh, look at that, we got some scroll bars. This is always an issue. For this, we can get rid of the default margin that's there on all HTML pages by, in the CSS, saying margin is 0. And just to make sure that the scroll bars don't show up, we can say overflow hidden. And by the way, I'm hitting Shift-Enter to run this. That's why it's not automatically running. Okay, so now that we've got this container, in our JavaScript here, we can get access to that container. And for the variable name, I'll just call it SVG. And for this, we can use d3.select and then pass it that ID. But since select works with selector strings like CSS, we need to add this hash to make it catch that ID. And since we can use ES6 imports, I'm not going to say d3.select, I'm just going to import select from d3 along with all this other stuff and run prettier to get the formatting. Alright, still nothing's going to happen, but let's continue writing this code such that our nodes will be displayed. So we've got nodes here which we want to create a circle, I'm thinking, for each of these nodes. And the nodes are not going to change over time, so we can just set up that D3 selection once and then just update the X and Y inside of the tick event. So here's what I'll do. I'll say SVG dot, and here comes the general update pattern. Select all, circle, and there are none at first, dot data nodes. So there's our data join, and we can say dot enter to get the enter selection, dot append circle. Okay, so far we've got a force-directed starter. Now let's bring in this data and try to achieve our original goal with this crazy graph viz. I'm going to start by forking this force-directed graph starter and then renaming this to be organization graph diagram. Let's revisit the original goal. The original goal is to create something kind of like this based on this data. But the problem is this is not exactly data in the sense that you would think of it. It's not a JSON file, it's not a CSV file. So our first order of business probably would be to create structured data from this using code. So what would the structure of this data look like? Well, we've got these main nodes that are bigger, and the things that are within these main nodes in the outline should be connected to these main nodes with edges. So these are essentially children of this parent. So in a sense, we're creating a graph data structure from a tree data structure that is represented roughly in this outline here. Let's start with something small. Let's start by making the Arts Web node connected to the Community Vision node, and also the Arts Web node will be connected to the Silicon Valley Creates node. So let's take this text, Arts Web, and let's instantiate this in our code. And I think this whole thing about generating the data is going to be a whole other can of worms, and this file is already around 50 lines. So let me just go ahead and before we even get into it, I'll create a new JavaScript module just for the data stuff. I'll call it data.js, I guess. And pasting that text here, Arts Web. And let's go to index.js and identify the data elements of it, which is this here, nodes and links. So I'm imagining that we just move these definitions over into data.js. And then we can export these. So export nodes, export links, and then in index.js we can import nodes and links from /data. Now this should still be working, and indeed it is. Now we can focus just on the data itself. Okay, so we've got arts web. We want that to be the name of one of our nodes. So let me just take that text and replace Alice with that text. Now, this node here will connect arts web to Bob. So now let's bring in some of those other aspects. In addition to the arts web aspect, we've got community vision. So we can turn Bob into community vision. And so now this thing represents the connection between arts web and community vision. I'll run prettier to get this on multiple lines. And lastly, we've got Carol. We can make Silicon Valley Creates into this node here, replacing Carol with Silicon Valley Creates. Okay, now we've changed the symbolic meaning of this stuff, in theory at least, but the structure is not right. What it should be is arts web to community vision. This one is good, but this one should be arts web to Silicon Valley Creates. So arts web, let's just look at the outline again. Arts web is the parent, the main node. So arts web is connected to this one and also connected to this one. To make that a reality, we just need to change the source on this one here from 1 to 0. Now this represents a connection from arts web to Silicon Valley Creates. But, looking at the output, you wouldn't know this. So I'm thinking now might be a good time to figure out how to display text on these nodes. That'll help us as we drive this forward for debugging purposes. So let's stop and do that. In index.js is where we can create text elements for these nodes. At this juncture, there's a number of ways we could go about it, but I'll just favor the simplest possible thing, which is just to have a bunch of text elements that are on top of these circles. One thing we could do if we wanted is make group elements, and then the group elements have the circles and the text, which we might want in the end, but let's just do something simple now, which is instead of circles, this can be text. Select all text elements, append the text, and then I believe the way to set the text content is to say .text, which is different than .attr, and then pass in node dot, what was it called? I think it was called ID. Yeah, node.id, node.id. This will just establish the text elements, but they won't be in the right spot unless we update them along with the circles in the simulation tick. So let's copy the logic for the circles and apply that to the text. Yeah, text is our variable name. And text elements don't accept CX. That's particular for circles. I don't know if it's like circle X or center X. Could be center X. But text accepts X and Y. So let's see if that shows up any text. And indeed it does. Look at that. All right, we're really getting somewhere. Okay, so from here we can go so many directions. One thing I kind of want to do is make the arts web bigger, because the size variance is something that we're going to have to deal with throughout this process of generating the data. So let's just start now. But what would the size be? I mean, we could attach something to nodes. Let's call it size. But, you know, what would the size really be? It could be like the radius of the circle in pixels. Yeah, let's try that. Let's say it's going to be 50 pixels. Now, if we want to instantiate this in the graphics, we need to go to the place where we're defining the radius of the circles and make this a function of the node. So node is the input, and we can say node dot size. This will break if there's no size defined. So let's just make sure we've got size defined for all of these nodes. These will all be smaller. Let's say 10. And let's see if this runs. Okay, I think it's working. But the problem is it's all sort of bunched up in here. We need to get some more spacing around it. How can we do this with the D3 forces? Maybe we can tweak many body. Yeah, d3.force many body dot strength and theta. I don't know what exactly these mean, but it says here for strength, a positive value causes nodes to attract each other, while a negative value causes nodes to repel each other. Similar to an electrostatic charge. That's cool. So the default is a function that returns -30. Let's try tweaking that. Over in index.html, we've got our simulation, and here we're defining the many body force. And right in here, I think we can say dot strength, and I wonder, can we pass in a number, or does it need to be a function? I would guess we can pass in a number. Okay, this runs, and it does the same thing as before, but if we make it like 90, does it do anything? Ooh, if we make it 1,000, look at that, it's spreading things apart a little bit more. I don't know if these values are like legit, but you know, it does what we want it to. So I'm noticing a couple things I want to correct right now, which is like the text, we can't read black on black, and the text is not centered. The text should be centered with respect to the nodes. So let's just work on that a little bit. How do we go about centering the text? I remember it is some attribute on SVG, and I always need to Google this one. If we Google SVG text align, yeah, we get text anchor and alignment baseline. Here we go. Text anchor should be set to middle. So let's do that. attr text anchor should be set to middle. And if I use prettier, it will replace the double quotes with single quotes. So if we run this, all right, look at that. The labels are centered, horizontally at least. What about vertically? They're a little bit too high. Let's try to center them vertically as well. And I think we can use alignment baseline for that. Yeah, let's just set alignment baseline to be middle, like this example. So what it should look like is something like this. It's almost exactly the same as this other line, but just it's alignment baseline instead of text anchor. So this should do the trick. Let's see. All right, looks decent, looks decent. But we still can't see the black on black. Let's just fix that real quick. One thing we can do there is set the color of the circle. I think I'll just make them gray for now. We can iterate later. And the way we do that is, I'm pretty sure we set the fill to be gray, like that. Gray is a named CSS color, that's why this works. Okay, and we've got this. This looks like a pretty decent starting point. Now, let's go back and continue working on the data. What are some of the next steps here? It's going to get more complex. coming back to this outline, we've got 20 smaller... All right, where should we go from here? I'm noticing that all of these nodes that are connected to each other are pushed away from each other with the same force, but the force really should be different, I think, depending on what type of node they are. I mean, the child node should be pushed away from the main node, like it is here, but all of these anonymous nodes, I mean, they could be closer to this child node. Let's see, how could we do that? Somehow, maybe the links could contain some information about how strongly they should be repelled from one another. Maybe here, when we define the force link force, we may be able to specify some function which is unique to each link that determines the strength. Let's see, we had force link is what it was called. Here's the documentation. Apparently there's something about distance and strength parameters for each link. Distance sounds interesting. Ah, look at this. If distance is specified, so the default distance is 30. Strength is a whole other beast. I don't think we want to touch this. Yeah, I think distance is what we need here. And it can be specified as a number or a function. And that function is invoked for each link. Okay, great. So over here, we can specify the distance like this. And that distance is a function of the link. And let's just return 30 for now. That's the default. Let's see, if we change it to 20, what happens? Not much. Maybe our charge strength is too high. That just seems too high from the beginning. If we make the charge strength 500 and then the link distance to be like 50, okay. If we make it 10, things are closer together. We're getting somewhere, but I want it to be different for each and every link. So let's just say link dot distance. And then when we generate our data, we need to attach a distance property to each and every link that we push. So we've got add child node with source and target, and here on this object is where we need another property called distance. And this can be perhaps similarly to size, we could pass in something, or maybe it could be a function of size. Maybe let's have distance be its own thing that gets passed in. And just like size, it can have some default, like default distance. And default distance we can define up here as 30. Sounds decent. That's what the D3 default is. And now, when we add the child node for each of these anonymous nodes, we can pass in, maybe let's call it leaf node distance. And we can define leaf node distance up here to be, let's say, 10. Okay, this is doing something, I think. Maybe let's just experiment. If we set it to be larger, then they do go farther away. See that? So this whole scheme is working, and if we set it to be smaller, they do go closer. But let's say if I put this to 0, this is as close as they're gonna get, and I think that's because the many body force is pushing them apart. So we can go back and tweak the strength of the many body force, which is 500 here. And you know, I kind of want to be able to tweak this from the same spot as we're tweaking everything else. So let me just do that. I'm just going to make this a variable called many body strength. And the value of many body strength can be defined right here as minus 500. And many body strength we can import from /data along with nodes and links. And over in data.js, we can define it, and we can also export it to make it visible. Okay, this is fantastic. Now we can tweak everything in one spot. So if we make many body strength like 50, ooh, look at that. Those anonymous nodes are right on top of each other. Maybe we can increase the default distance to be like 100. Hey, look at that. It's getting closer. Leaf node distance, I mean, we can push those a little further apart. So maybe 20. Yeah, we got some variation now in that. And let's see, default distance, let's try 200. I don't know, maybe 150. Okay, we're getting somewhere. We're getting somewhere. This is looking pretty okay. The readability is a bit off, but that can be a final pass. I think what I'd like to focus on next is getting this structure working for all of our outline. Yeah, so we're still in the middle of this arts web. After that, we can move on to these, but we still need to add the 20 smaller unidentified nodes to this Silicon Valley Creates child node. So let's do that in here. We are adding 20 child nodes, and we want to do this again for this child node here. So maybe what we could do is just copy this exact same pattern and just change community vision to Silicon Valley Creates. So let's try that. I'll just copy this entire thing, paste it here, and then change community vision here to Silicon Valley Creates. Now we've got this block and this block essentially copy pasted, and let's see if that works. Ooh, child node has already been declared. Yeah, that's the thing about const. If you use const, you're not allowed to reassign. So we can make that not break by using let instead. And then down here, we don't need to use let again, because here it's defined, it's assigned, and then here it's assigned, it's reassigned. It's reassigned, and that's what let lets you do. Okay, this is working. Hooray! Now, it is a little bit of a bad code smell, in my opinion, to have such copy-pasted logic. So let me go back to using const, and what I'm thinking is we can encapsulate this into a function so that we can just call this function again and again for each and every child node. I'll comment out this for now, and this one I will put it inside of a function. I'll call this function maybe assemble child node. Yeah, so we've got this function, and inside the body of this function we can put all of this logic just like that. I use prettier to format it. And the only thing that's going to be different is the name here, this ID. So what we can do is just accept that as an argument. And this here can be simplified with ES6 syntax. It's the same as this here. And now we can invoke this function, assemble child node, and pass in this string here, community vision. So now if we run it, we only get community vision. But now that this is set up like this, we can just invoke that same function again and pass in Silicon Valley Creates. And now we get both of these here like this. Okay, sweet! That's exactly where I wanted to end up. Now we don't have this sickening duplicated logic, and now we can go all out tackling the rest of the outline. Okay, now we are done with this part. Let's do now this part. Okay, so we're introducing another main node. Let's start there because everything else is going to be attached to that. It's called Social Impact Commons. What can we do for that? We need to invoke add main node again. And this is where I think we want to essentially copy this pattern. I'm just going to paste that text, Social Impact Commons, and then I'll copy paste this chunk and change Arts Web to Social Impact Commons. And when we run it, we get that issue about const. So this is where I think I would like to use let here. And just a pattern I like to do with let is just declare it once so that it's clear that it can be reassigned, and then assign it in multiple places like this. So now if we run this, there was another parent node. You see it sort of ends up moving off to the side because it's not connected to anything. Let me just tweak these constants to make sure that it's in view. I think we can do that by increasing many body strength. So if we make that again like -500, oh, that's pushing it away. So if we make it small, -30, things are not pushed away as much. Okay, that's what I'm after. I don't know, -10. Okay, now Arts Web is there on the screen. At least we can see that it's there. And actually, at this juncture, I'm wondering, should there be an edge between these two main nodes? Let's refer back to our original example. In this example that we're trying to emulate, the main nodes are all connected to one another. So now that we've got two main nodes, let's just add that connection. That will solve the problem that that thing is floating off. All right, so the way we can do this is we want to add a link between these two parent nodes. This is where it's kind of problematic that we're using the same name for both. So, I think I'll just rename this to be Arts Web. I think this is fine because there's not going to be that many main nodes. We can have a variable for each. Now we can go back to using const Arts Web and then pass that in here. And now we can have another const Social Impact Commons and add that there. But I think we might be referring to parent node down the line. Yeah, here we're using add child node parent node, but the parent node is going to be different over time. So I think what we want to do is accept parent node as an argument here, and then when we invoke this assemble child node, we should pass in Arts Web as the parent. Yeah, I think this is the way to go. Okay, now this is still running correctly, and now we are in a position to connect these two main nodes together with links. And this is what we've got so far, but it's still a far cry from this example, which we kind of want to shoot for this aesthetic. We have a lot to do, like tweaking the parameters of the force, changing the sizes a little bit, working on the text wrapping, but I think the first thing that would make sense to focus on is the colors. Notice how each set of nodes has colors based on its main node, which we're calling it. And this is related to the data. I mean, we're going to have to come up with these colors in the data generation part of it. So yeah, let's go ahead and try to add the colors. In the code, the colors, well, we can maybe modify this add main node function to generate a color for each main node as it gets added. But first, we're going to need a source of colors. There are all sorts of color palette generators out there. I think somebody once recommended Paleton to me. Looks like a pretty neat tool. But how many main nodes do we have anyway? How many colors do we need? It looks like we have 4 main nodes: Arts Web, Social Impact Commons, Cast, and Ambitious. So we only need 4 colors. That's great because Peloton only gives us a max of 4 main colors, it looks like. And we can drag this stuff around to sort of tweak the aesthetic. So I'm just gonna, tweak this stuff until something kind of pops out. I mean, that looks decent. Let's try these 4 colors. I think we can export this. Yeah, this is cool. It's nice that there's light and dark variations. We could try these out. Here's what we get when we generate the text export. So let's take this as our input. And the color definition is a whole other thing. So I think I'll make a new file called colors.js. And then I'll paste all that in here. And I like having all these different shades available because we can pick the shade and tweak it later. So let's get this into a structure that we can use. We're going to want to export const colors equals, I'm thinking it'll be an array of arrays. So it'll be an array. And then I'm going to use my Vim superpowers to essentially crop out the parts that we don't need. And yeah, so I'll just delete that. I'll also delete the rest of this. And now this is pretty close to an array of arrays. We just have some extra new lines, random text. We need to surround these with quotes to make them valid strings. So we can append quotes to the end somehow. But anyway, this will be the first array. This will be the next. This will be the next after that. And this will be the last. We close it out. Let's see if macros work in here. Looks like they do. So I'll end quote, put a comma. Okay, this is what we've got so far. I'm looking at just spending, as little time as I can to get something presentable from here. So we can, deliver something. One thing I want to do is make these colors propagate to all the nodes and then do a stylistic pass and tweak all the parameters of the force layout to get it to look decent. So let's start with looking at these colors. In add main node, we are assigning node.color when we add the main node. So what we can do is when we add a child node, we can just carry over that color from the parent node, which we do have access to. So let's try doing something like this. Parent node.color is what we want to use as child node.color. So we can just say child node.color equals parent node.color, and voila, look at that. The colors have been updated. It would be nice to make the links also have the same color. Right now the black is pretty harsh, and it would be nice and smooth if it was the same color as the nodes. So let's try that. Alright, so in add child node, we're assigning the color of the child node, and we're also adding this link. We can just take parent node.color and assign that to a new property on the links we can call color. So color is parent node.color, then format that with prettier. Now we can access color on each and every link object. So in our rendering logic, we can take advantage of that. Here we're rendering the lines and we're assigning the stroke to be black. Instead, if we assign the stroke to be a function that takes as input a link and uses link.color, or if there is no link.color, we can use black. This should do it. Alright, look at that. The links are the same color as the nodes. But the links are on top of the text. That's just an ordering issue. I think we can fix that fairly easily. We just need to be sure to add the text after we add the lines. See, right now, we're adding the text and then we're adding the lines. But if I just swap the order of this, I'll just cut that text and paste it to be after we add the lines. Okay, that problem is solved now. See, the text is on top. I kind of want to color these black lines that connect the main nodes. Let's do that. Here in Connect Main Nodes, we can just assign a color to these links. And let's just arbitrarily say that we're going to use the source color. Okay, cool. Now they are different colors. At this point, we can start tweaking. One thing that I notice is that the black on this sort of dark color is not that readable. I think we can go up one shade, make it a little bit lighter. And recall that in our colors, we're using the shade at index 2. So if we just change this 2 to 1, we get nice light colors. Okay, that looks better, I think. Another thing that pops out is we're using the default font, which I think is like Times New Roman or something. We can use a slightly nicer font by specifying the font family to be sans serif. Okay, that looks a little better. The problems now are, issues of overlapping text, and the layout is not quite right. Let's see what we can do by tweaking our various parameters. I'm noticing we have this default distance, but what I'm really looking to do with this tweaking is to make the main nodes farther apart from one another, but not impact how far apart the child nodes are from the main nodes. So I think I would like to introduce another constant here, like main node distance, and then use that when we add the connections between the main nodes. Yeah, when we connect main nodes, instead of default distance, this should be main node distance. Now, if I increase main node distance, they should be a little more spread out. One thing I'm noticing is that all of these nodes seem to be bunched up, and I think these are the ones that don't have any anonymous leaf nodes. Maybe we can just add a couple anonymous leaf nodes for those, like maybe 3 for each, just to make them spread out. And I kind of wish that I could just drag these around to position them to, avoid the overlaps. That would actually get us to something presentable. Luckily, there's a module that we can use that does exactly this, D3 drag. Here's how we can use it. Instantiate a new instance of d3.drag. To do this, we can import drag from D3 and then introduce a new variable, which is a new instance of drag. Let's call it drag interaction, just so that we don't conflict with the variable name drag. And here's how we can use it. We can select the nodes and then use .call and pass in our instance